And moving now to kind of getting into what full stack engineering really is, particularly as we talk about the software stuff. We'll get into deployment. We'll get into microservicing. We'll get into MQTT. We'll start talking about security and stuff next week. Basics of the API securities next week. Then we'll get really deep into some front end stuff, some really advanced front end in React, which I think you guys will like. It's very systems oriented, very interesting, um, and stuff. But today really starts kind of the beginning of I would say slightly more advanced. This is I would say that most software developers who have worked for probably about a year, maybe two, have the general understanding that you guys have in terms of what you've been exposed to at this point. Obviously, they'd be smoother and stuff on the coding. This isn't really a coding class, right? It's not a coding boot camp. It's a concept boot camp. And then you guys develop kind of that code. It takes time. That's what I was telling Arif before. It takes time to develop the code. Don't really expect you to be awesome coders by the time you get out of here. But you don't have to be an awesome coder either. It's a tool that you use, right? So it's really more exposure to all the concepts, the words, the language, and then we'll get into and then you'll basically be armed with the concepts that you need to go out and really do good. Um, there are still roles, and we'll talk about this, as Modesto, as we near the end, what roles can actually be filled, even if you're not comfortable with the coding yet, which I don't really expect you to be. There are still roles to be filled in the context of stuff to do, which is good, even without that coding. So today is really where we start to connect the more advanced concepts like databasing, which is today. More advanced front end stuff, microservices, MQTT, optimization in the cloud, even a little bit of machine learning in the end, stuff like that. So really good stuff. So let's see. I got a few slides. I want to kind of motivate what we're doing here. Just like 5 slides. I kind of want to motivate what we're doing and give you at least a little bit of exposure and see some words and logos and stuff of the technologies. So after today, I expect you to be somewhat dangerous with databasing. As engineers, particularly like test and automation engineers, we don't typically use databases. Well, we use databases all the time. We just don't really use them in the sense of how we're going to go into them today. Databases we use, right? We use Excel all the time. I'm sure you guys use Excel on a daily basis. Those of you work in a general engineering field, and then you might even use Microsoft Access. I'm sorry if you do, but you might. I don't know how much of that stuff is actually there. You might have come into contact with SQL Server, Microsoft SQL Server, but today we're going to talk about really more database technologies that you're going to be exposed to nowadays when you need to go to scale. There's very few applications nowadays that you can get away with not designing for scale. And what I mean by that is, if you're developing a new system, chances are it's going to be collecting lots of data, regardless of what area it's in, and you have to design it. And so the things that we typically used in the past, like Excel workbooks and stuff like that, Access databases, that just doesn't cut it, right? So that even numerical scientific data, you store it in a bin file or a mat file, or you store it in a CSV. That's not sustainable. There's just too much data. And so we're going to be exposed to data technologies and data structure technologies that you could, if you listen today, can probably start using tomorrow, putting all your data into from a powerful. That's pretty much how powerful it's enough to be dangerous, is what I say here. All right. So, why do we need databases? Well, this should be obvious to everyone. It's in the name, right? Data persistence. We need data to stick around for longer than we need it in volatile memory. And I think the biggest one that a lot of people don't realize who don't really understand databasing is you need data access efficiency. When we talk about accessing data in like an Excel spreadsheet, that's a very, very tiny amount of data, right? I mean, it's what you're limited to, like what, 65,000 rows or something. There's some. I'm sure everyone's run into it, right? There's some amount of rows you can't store, above in Excel. And when we talk about data size, that's like minuscule, so tiny compared to the types of data we typically think of when we say that you should really use some sort of database, like a relational database or NoSQL database. Um, there are two, but I added a third, really core types of databases. The first one is relational. That's one that we're all familiar with. The second is non-relational, and sometimes you'll hear it called NoSQL, colloquially NoSQL. And then I'm adding one, and it's rare you'll hear this, but I've heard it before. But I like to think of it in terms of a cache database. And these are going to be low volume, but extremely efficient and rapid read-write steps. So we'll do 3 examples today of databases, touching on each one of these. So let's talk about the relational databases first. So relational databases, everyone always asks, like, how do I choose? I mean, is there one that you typically use? Well, typically you'll see the database choices based on what people are most comfortable with, right? I mean, that's pretty typical. Any tools like that. And Modesto Technicity, we typically will we use the database that's good for the application. So you'll see kind of a mixture of database technology between relational, non-relational, caching, stuff like that. So when you say, all right, what kind of data do I, how do I choose a relational database in this example? Well, an example, and what I always say is, if your data can be easily organized and it's very flat. What I mean by flat is it's basically like there's no nested hierarchy to your data. It's probably really good for a relational database. And the biggest kind of like gut check on whether or not your data is probably good for relational is whether or not you can very easily, very quickly think of your data fitting into an Excel spreadsheet. If it fits really nicely into an Excel spreadsheet or multiple workbooks with a few links, it's probably pretty good for a relational database. So some of these technologies are an example, like in the context of what we were doing, the vehicle metadata, right? Make, model, year, those types of things. Very flat data, right? Maybe business structure, right? Really flat data. Accounting, really flat data, right? Really good for a relational database. So some technologies you'll hear, MySQL, that's what we'll do today. Postgres, Oracle, that's kind of, you ever wonder what Oracle does? Well, that's what they do. They make databases and products that are supported by databases, right? And then Microsoft SQL Server, and there's a ton others. Relational databases are probably the oldest kind of understood technology in databasing, and they're still heavily used today. You see a bunch of logos over there. A lot of them you probably have seen or recognize. And then there's non-relational databases. These are the kind of the new kids on the block. You probably hear a lot of hype around this. Very trendy to do, especially in the context of big data. This non-relational databases are really good for data forms that are not easily or flatly organized. Now, what does that mean? Well, in the example that we had is for relational data was our vehicle, make, model, right, color, just things that are just basically data attributes. Pretty simple. But if you have like nested data, like text, or even nested type of struct. So if you're a MATLAB, if you remember back to your MATLAB, you make a struct, or C program, you make a struct, and that struct might have nested fields associated with it. Or you can think of JSON having those nested kind of fields, nested object. Those are really good for non-relational databases, NoSQL databases. Now, where does it get the name NoSQL? Well, relational databases, the language you typically use is SQL. Almost all relational databases have some sort of SQL, that's the language, and we'll see some of that today, access. In NoSQL, it's kind of a colloquial or kind of, term that we use because most or a lot of non-relational databases don't have SQL mapping. And if they do, it's a weird version of it with a lot of different stuff, as you can imagine, right? So, because they're very different. Some of the technologies today will use MongoDB. That's probably one that you've heard. In fact, they had an IPO, I think last year or the year before. That was kind of a big deal in the community. Successful IPO. Cassandra is another one. That's an Apache project, really big, used by Netflix. They kind of pioneered that. HBase, that's a big data one. You'll see a lot of HBase and Hadoop, if you heard of Hadoop and big data and stuff like that. Spark and those types of technologies. CouchDB was kind of one of the front runners many years ago. They kind of led the way in non-relational databases. ArangoDB and Neo4j are graph databases. So you know you can imagine graph patterns. They're very, very cool. A lot of people try to use graph databases whenever they can because you know most data is connected in some way. That's not the way to do it though. Graph databases are actually only good for very few problems. A lot of people try to force it kind of into it because it's a really cool concept, but they end up getting burned. We'll talk a little bit more about that. And of course, there's many, many others. And in fact, next we'll talk about cache database. I say it's a special mention because some people will probably disagree with me. In fact, most of the time they're going to group what I call cache databases into NoSQL databases, key value stores, right? So you have a key and a value store. In fact, if you think about it, a JavaScript object, stuff that we've been talking about, in and of itself is kind of a non-relational mapping. It's a non-relational database because you have just nested objects all the way down. And so but it's a key value pair kind of structure. And so when you have data that needs extreme read and write speed, meaning you got data coming in, you might need to read it really quick out, and it's low volume. So maybe the latest data from an IoT edge device, like that vehicle, right? Because we may want to read that latest data all the time, but we need to write it quickly. A cache database is really good for that, and where you don't need to maybe store it for very long. And so you'll hear about Redis. That's what we use today. There's another one called Memcached, which has been very popular over many years. That Redis kind of edged out, but you'll still see a lot of it. And you know, many other non-relational databases they'll claim are good for it. Like you'll see MongoDB being used sometimes as a cache database. I don't support that. I think it's very slow. Writes are slow. Or reads are relatively slow. Writes can be fast, but reads are slow because of the indexing and sharding and all that kind of stuff. But really, like I like to really separate them into relational, non-relational, and caching because they're very unique sorts of strategies. Any questions so far? All right. There is one relational database I didn't mention, Clayton. What is that? It's your favorite, SQLite.
Yeah, SQLite.
There's tons of them, but actually you could the way Clayton uses SQLite is very non-relational. That's the thing. Between you might say, well, you know, is there really a lot of difference? There is a lot of difference in how you should use them, best practice. But you can store relational data in a NoSQL database the same way you can store non-relational data in a relational database. Because you could just make one column a key and then just dump the rest of your data in one value, right? In a relational database, just like an Excel spreadsheet, right? You have one row with two columns. First row is the key, and then the second row is just a bunch of data in that one cell, right? And it's like mapped in a specific way. You can do that. It's just not very efficient. So you can pretty much structure your data however it is. It's more about flexibility and the speed in which you want to access that is how you make your decision. So when you're thinking about databasing, these are basically the four things I think about when I'm trying to choose or just kind of approaching a problem. I think about structure and data model. And in fact, when we started this semester, started the boot camp, we didn't typically when we start a project, we actually start with a data model. We don't actually start with routes and things because the data model ends up informing the routes. But we actually kind of turning it on its head because if we were to start the course with databasing, wouldn't come together very well. So pedagogically, we had to start somewhere. But typically, when you're designing a new system, we always start with the data model. And there's three V's of data. You probably heard this before: volume, velocity, and variety. Volume being how much data is there going to be, the velocity, how fast is the data coming in and out, and then the variety. What types of data? And when we say what types of data, is it string data? Is it numeric data? Is it textual data? Is it contextual, like semantic data, like social media words, things like that, things that you'll need to do natural language processing on? All of the different, like the variety. That's kind of where everything else gets thrown into. All those three V's really dictate what kind of databasing you're going to go for. The next one is index performance. In databasing, we think of there's a very very clear there's a very clear concept of an index. And index is on both relational, non-relational, the caching that I talked about, and everything. And basically, an index is what data needs to be accessed most frequently. So underneath the hood of all these databases, there's a strategy in which, with mass amounts of data, you can imagine it takes a lot of time to find something, right? If you have gigabytes of data, even if it's well organized, it's still going to take some time because you have to, you usually can't get around iterating through at some point, right? And so there are strategies to index databases, which means these are kind of metadata fields on top of your data that say, look, this data, it gives us as the developers an indicator, a marker that kind of hangs over the rest of the database that points to parts of the database. And we set those indices. And what we're telling the database technology with those indices is this data is most frequently going to be searched, or I need this data, this specific thing, to be searched most often. So therefore, prioritize it when you go and search. So they kind of give us that ability to prioritize where and how things get searched inside of our database. And that's what we're talking about, index performance. What data needs to be accessed frequently and how. There's oftentimes, if you're like, man, this database stuff is so slow, like I'm spending like a 2 or 3 seconds accessing this data and I shouldn't be, it's probably because your indexes aren't right. We've improved system performance 10x, 100x in some cases just by doing a simple index. It's really important to know SQL databases and non-relational databases because that's kind of all over the place, right? There's this proliferation of data structure everywhere. So indexing is very, very critical. And then the next one.
Sorry, can I just ask you a question about that?
Sure. Yeah.
When you index like that, I'm sure that you'll show us this, but is that have to be done kind of manually by the developer, or can you automate it? So like I know with tagging data, that often it depends on how you do it, but sometimes it has to be done very manually. Sometimes it can be done in a very automated fashion. Is indexing something that you as the developer have control over and you have to tell it what the index, or is there a way of automating that to a certain extent?
There is a way of automating it if you're willing to wait for the system to learn where the speeds are. Typically, you're going to make your best guess as a developer and index things. And then there's an automatic automation step of determining index. MongoDB has a very nice feature where it will suggest indexes for you because it's a relatively simple thing, right? Like if by just simply running some very, very straightforward analytics, what are you calling most and how long is it taking? Well, by just simply, taking the statistics of that, saying, hey, you're calling this data the most and it's taking this long, why don't you index it because there's no index on it? And then maybe you'll do it. Now, if you just automatically index something, you can't have your cake and eat it too. What happens, like in anything, what ends up happening is you can over-index. Where if you index every single data thing in your database, what's the point, right? You're just stuck again with, you're really not getting any advantage, right? I mean, you've just said, well, look everywhere. So you might as well just not have indexed anything at that point. So you have to be somewhat judicious with how you do your indexing. So you still want to have somewhat of a tight kind of hold on what indexes are actually being applied and when. Because there may be a case where it's like, man, I really wish I could index that, but not at the expense of this other operation I'm doing. Maybe I'll move that into another database, or I may, which leads us to the next one, partition better. This next one is partition performance. And where indexes are all about, maybe a column of data or a specific row in the data, more about column, partitions are about chunks of data. So imagine that you have data that's sectioned by year, and you might have terabytes of this data, right? So let's say it's scientific data coming off of a Boeing 737, right, or something like that, and it's just terabytes that get dumped every day from these things, right? But one thing is that, well, I probably don't need data. Like, I need to keep it in the same place because I need to do analytics on it, but I probably don't need to prioritize the data that is maybe 3 years old or 2 years old, right? So at that point, that's about partitioning. So you can chunk out. So it's not now about specific data or specific columns, right, in your data or specific data types inside of a row or a record. It's about chunks of data. You say, I still need them in my data set, but maybe I can preferentially select or search the ones that are newest or latest. Or in the case, maybe there is a case where you actually have to search the oldest ones. At that point, you partition appropriately. And partitioning is difficult because, and the reason partitioning is difficult is certain database technologies support partitioning, some of them don't, and there's a lot of things that go into it, like foreign key constraints and all of those different things, which we'll go over today, that really impact your ability to do efficient partitioning or partitioning at all. So you have to be somewhat aware of that. Partitioning doesn't really become a big deal until you have mass data. And we're talking about tera to petabytes level data. And typically, what I've seen in even in huge data type things, typically if you have a production data where you're constantly accessing it, typically those partitions, you've already removed them from your data store and put them in what we call cold storage, which means we're putting them into maybe a similar looking data space and data structure, but it's not hot, meaning it's not being hit all the time from a production standpoint. We're basically moving out our data and just cold storing it until we need it again, because we don't need speed when we need it again. So that's really kind of where we're at in terms of the partitioning. So the top two are, of course, our data model and index performance. Those are the two kind of things you always got to be thinking about. And then the fourth one, and this comes down to deployment and things. This will become more obvious when we start doing deployment and talking about, how do we actually get these systems out into the wild, and that's location and configuration. Now, the word location is weird, I think, because what does that matter, right? We're in the cloud. It's everywhere. Well, not really. And then, of course, configuration. So let's talk about location first. Where is the data? Now, like I said, you might say, well, it's in the cloud. Like, what does it matter? No, that's not really that's not the case. No. Not the case at all.
Where's the server?
It's having dealt with a lot of worldwide systems, time to get data to Australia is a lot different than trying to get data to Chicago, time-wise. That latency is pretty serious. We're talking 3, 4, 5, sometimes 15 seconds on some really bad routing. And so, it really matters where your data is. So if your actual database on the virtual machine, databases are just deployed on Linux servers. Like, there's no magic there. It's not like there's special hardware that database runs on. No, they're just running on operating systems that are optimized for certain activities, file systems that are maybe optimized for this, but they're just servers. If your database is sitting on a server in Australia and your application code is sitting on a server in Chicago or Central, GCP Central, Google Cloud Platform Central, that's not a good thing because you're going to be waiting a long time just to get your data. So the idea is that you have to worry about where these things are with respect to where your applications are and where your end customers are too, where your consumers are. And that's why globalization starts to become such a frustrating thing, and what we call regionalization in computing, in cloud computing. Time in Russia is a lot different than time in North America, which brings us to what's your resiliency plan? So you might say, wow, that seems like a really tough problem. How does Google do it? How does Facebook do it? They've seemed to figure it out. Yeah, they have, because they use things called replica sets and resiliency and failovers. So what happens is you actually will keep multiple copies of the data throughout the world in different regions. And then you have these massive processes, and you work with places like Hurricane Electric and a number of different internet backbone service providers that manage, the massive cables that are under the ocean to prioritize your traffic between your data centers. And you have what we call replica sets. So the same databases might be in China and in North America, and then every time something that may be a master in North America gets updated, a record, it immediately kicks off a job to then go update it in China, so that the applications in China are still responding at the same rate to what a person in China is accessing or in that region looks like it is, but it may actually be a microsecond behind or a millisecond behind in terms of latency. But to them, their user experience isn't affected. So that's kind of how they get around those things, is replica sets and everything, regionalization, and there's sophisticated tools that are used. Typically, we can use tools, and a lot of that is just taken care of for us. And that's what one of the advantages of going to the cloud is, and letting a platform as a service like AWS or GCP or someone manage all that for us. If you're doing on-prem management, then you got to manage all that. Like if you're Ford and you're managing your own servers in your facilities, well, you've got to figure out what that resiliency plan, what those replica sets are in all of your regions across the world. That's kind of a pain, right?
Is resiliency only about your data and your data structure, or is it about the structure around it? Because I've not used that. Resiliency, that's not a word I've heard used the way you just described it.
Yeah,
So
so
that's new.
yeah, and I'm sure Eric, who's on, if he's listening, is probably like shivering, like that's not what resiliency is, because he is, that is his area. In terms of databasing, we do refer to it as resiliency, and because replica sets um, are really designed for as backups and failovers, but they give us kind of the added benefit of this regionalization and spread. And so we typically refer to it as a resiliency plan because it is a backup. So let's say you might have a master in North America and a slave in I can't use those words anymore, but slave in China. Primary and secondary, whatever, a primary replica set in North America and China. If the North American primary goes down, you can always quickly recover by pushing the secondary from China into North America again. So that kind of provides you a resiliency plan in order to assess that, and you can use assessment techniques and everything to verify where the weaknesses are, and how much data is actually going to be lost if one goes down at that time, if there's any loss at all potentially, and there's plans on how to do that. So that's why I'd say, what's your resiliency plan? It goes beyond just regionalization. Regionalization is the thing you get immediately, as opposed to what you also get is that backup, which you hopefully will never need, but it does give you that added benefit.
Which I got a question on the same configuration. You just mentioned how the geographical distance plays an important role when it comes to the latency aspect of it,
Mm-hmm.
and how Facebook and all the other big social media companies have a way around it using this replication plan. So is there something when it comes to automotive, like likes of Tesla, is, I mean, safety critical if you're talking about autonomous driving, and where they use huge amount of high definition maps and everything? I'm not sure. I mean, I don't have complete understanding if it is accessed via cloud, or is it already burnt into a vehicle, already downloaded onto the vehicle. But do they do similar thing based on where their market is? Like,
Right.
I'm sure they have a market in Europe and Australia as well.
Sure.
So
Yeah. Most of the actual from an ADAS perspective,
Mm-hmm.
There's a significant amount, a lot more than the average connected product. A lot more computing goes on in the vehicle
Right. Yeah.
because of the safety critical and the decision making speed that needs to be done. So the high precision maps and all that kind of stuff. Typically, the vehicle will actually request the next couple blocks, of data, and then it'll grab it, and then it will process that as if it was local, local kind of stuff. There's a lot of additional dependence on the awareness of its environment using lidar, image recognition, computer vision, all those different technologies, as well as V2V, right? Communication with other vehicles, if available, and not really available yet, but will be eventually, right? Um, it uses a lot of those types of tools to make local decisions, and it depends on the cloud and these databases to then give it, chunks of its high precision mapping or predicted weather patterns or predicted traffic patterns up ahead. That's where it gets that information from these types of databases, and that then it's regionalized. The other thing is from a connected product perspective, it's all about your load balancers too, right? Where you're actually connecting from. So a lot of the tools that we use are very intelligent. There's a lot of stuff that goes on. We don't even think about it, but there's a lot of things that go on where we're actually connecting. There's a lot of intelligence to figure out in those load balancers when you're connecting where the closest place is. And that's simple physics, right? What place is getting you the fastest, right? Path of least resistance sort of thing. And so it's all that IP stuff is working, and it knows that you do, like, you're in central region, you're going to go to that central region database. Well, actually, what you'll do is you'll go to the central region load balancer, which is connected to the central region application Docker containers, which are then connected to the central region databases. So it's kind of that stack, right? And so that's how that intelligence sort of works itself out all the way through. It's not as complicated as you might think. Like, oh wow, geez, how do these things decide how to, which one to connect to, and what North America and China? No, it doesn't. It's not that complicated. It's all about that front kind of the front line, those load balancers, which we'll get into with deployment stuff like that. See, this is where the system stuff starts getting really cool. We've kind of struggled up to this point, right? Just trying to get our Docker containers and remote environments working and stuff. And I think we're all there now, which is great. But now we're really going to start to see the system stuff come together. This is where it's really really cool. All right, so I think that's all I had for kind of talking points. So let me set this up. Any questions while I'm getting this running?
So I have one question. So when you talk about databases, that's a part of AWS or cloud computing, or is it still separate from that?
So you mean like the databasing is still separate? No, that's one of the primary roles of an AWS. Is in fact AWS, GCP, Azure, the big cloud platforms. They all have a very sophisticated managed database products.
So
That you
as a tools engineer, we will be working using any one of those platforms to access the data.
correct, yeah. You will rarely, like in development, you'll deploy your own. Like us, we'll be deploying our own Docker containers. When you go to production, you don't want to manage your own databases. You want someone else to do that for you. So you'll buy, you'll rent, AWS Aurora, which is a MySQL implementation, or RDS, a relational database system, right? GCP has managed, MySQL, and we'll go over that in a couple weeks when we do Docker containers and stuff, or deployment and stuff. So, all right. So I'm starting here. I'm going to my boot camp. Nope, that's not what I want. All right, boot camp. And I'm going to pull down week 4. We're just going to start from week 4. Actually, here. I'm going to pull from the development environment. So this is kind of what we did in this is what we did Tuesday, for those of you who were in the office hours, where we spent a lot of time with Beth Ann's thing, which we ended up fixing, which was good. It was just a reinstall. You just needed a reinstall. But so I'm just checking out databases here. Let me move this closer. Jeez. All
right, VJ, since you are having fun with this too, is there a decent way to actually split your screen for in a Mac like you can in Windows to have them equally split the screen?
I just did it unintentionally, but yeah. So this like that, you can drag it and drop it on it, and there you go. It's split. I don't know if you could see that, but
okay, yeah,
that's kind of the same thing. I hate that. I don't like doing that, but yeah. All right. So you'll notice here I created another branch called databases. So I just checked out that. I'm just gonna check out this branch. I just did it. I'll do it again. I'm gonna open up my VS Code, and we'll notice there's a few changes, a few additions to the Docker Compose. I've added, so you'll notice, I'll go to the bottom here. This is our dev container. This is what we've been using up to this point, right? We've exposed 9,500. I've changed this to 5,000, but 3,000. I've commented out sumo because we don't need sumo quite yet. But I've added 3 other containers. And those 3, the first one is MySQL, which we talked about. It's a relational database. I added Redis, which is kind of we'll use as our cache database. And then Mongo, we'll use as our non-relational database. And so we've got all of those, and I should hopefully be able to open this in my VS Code here. We'll wait for that to open. Let me pull up my thing here. Should be good to go. Trying to find my my thing here, so I actually don't waste you guys' time. There we go. All right. So we are good to go. Looks like it did not fail, so that's good. And we are in. Okay. So in the README, I gave you a couple of different. I really appreciate you guys asking questions, by the way. It makes it a lot more fun for me. So in the README, I added a few different things here for accessing our databases. So if we go to our README, we can access MySQL running this. And so MySQL root P. So U is the user name, root, and P is the password. Now, where did that come from? Well, if we open up our Docker Compose, you'll notice that as part of this MySQL container, which I can grab from Docker Hub, it's just a pre-built container. It's this container. If you just read the docs, you can see there's a way to set these different things. Starting a MySQL instance is simple. You just run it, and then you have to say your root password. And so if you look at a few other things, it'll tell you exactly. So you just read the documentation. There's no magic in this. MySQL root password, MySQL user password. And all I did was I set them. And so this root and root came from there. So if you want to change them in your Docker Compose file. Very simple. And I just made them all the same to make them easy. You might say, well, what's the difference between root password and MySQL password? Well, the root password is, well, root, right? That's the primary user, the super user. And then the MySQL password is basically our user password. We typically in Docker containers use root, and the reason is because one, it's easier, but two, it tends to be just as safe, just given that it's already containerized, sandboxed, and all that kind of stuff. So you can in MySQL create multiple different users and give them different permissions and all this kind of stuff. If you're running like an analytics server where you only want a specific read access to a database, which is important, so you can't modify it, then you create a new user called like analytics or something, and then you would just give them read privileges, things like that. You can read all about that. We're not going to go over the details of that. Every single database that you use is going to be different in how it gets configured. All right, so that's where this comes from. So MySQL-u root-p root-h, meaning host, MySQL. You might say, wow, that looks weird. What is the host? Anyone tell me what the host is? What's the host?
Yeah.
Yep. What's that?
Docker container running in dev container.
Yeah, it's the host is basically, generally the host is where it's running, right? That's the address of where it's supposed to be, and that's the name of the Docker container. So you're right. So not Anna Reeve, I don't know if who beat you to it, but so basically this could also be localhost, right? Actually not, and the reason is because you're not actually running the MySQL in the Docker container we're in the dev environment. We're running it as a separate Docker container. And in fact, if we do a Docker PS, which is not going to work there, because I'm in the container, if we do a Docker PS here, we'll notice, this is on my Mac, my host machine, we'll notice that there are 4 containers running. The first one is the dev container, right, that we're logged into right now. Then there's MySQL, Mongo, and Redis. So 4 different containers that are running, and they're all connected via our Docker Compose. So you can see that dev image container depends on MySQL, Redis, and Mongo. And by saying MySQL, we can basically set the host to be MySQL. So MySQL is basically like a IP address or a host name, if I could spell it right. There it is. We're in. Pretty cool.
So BJ, the code in the README is slightly different than that.
Is it? I may have.
Yeah. Well, that's okay. It's just my SQL. Yeah. Does that matter? Like the user root. So you shortened user root to be u root.
Yeah. Just dash u. This will work. I actually did this for you guys to make it a little bit more clear because I hadn't talked about it yet. Thanks for calling that out. What I used was shorthand for it because it's quicker to type and you end up typing this a lot. And so it's just dash u root, but this won't work. I guess it will. This dash u space root and dash p, it's just how the interpreter kind of processes it. But you see that dash p didn't work because it thinks that it's dash p space, which is not part of the password. So it's asking for a password. And then of course it doesn't work because it it had the wrong user. So typically we'll just do that to eliminate the spaces. So it's just a style in which we're entering it. This should still work. Let me verify that. Yeah, same thing. So, all right, a few things about MySQL. So you're at a prompt, and unfortunately, guys, I know you by now you should all be experts in Node and Python, right? After our 4 weeks. That's a joke. You're not supposed to be experts. Well, we're going to introduce a new language called SQL. It's an awful language. Freaking hate it. It's so bad. It's one of the oldest languages too, as it turns out, and it's still so used today. There's a lot of people that love it. I don't know. Are there very many people that actually love SQL?
I've never met one.
Okay, so okay, never mind.
I love SQL.
Clayton, seriously. just being ornery. No, SQL is awful, and you'll start to see why. SQL, like, it makes an attempt to like make it read like it's English, but not really. It's a very archaic sort of look, very COBOL-y. If you ever program in COBOL, I've never programmed in COBOL, but I've seen some. So let's take a look around MySQL a little bit. Well, we can say show databases. Now you'll notice that I'm doing all capitals. That's very stylistic. You can also do lowercase, show databases. I tend to like the uppercase because it's indicating what is a keyword in SQL. That's just stylistic. You don't have to. If I get lazy, I might actually not do all capitals. So what I'm doing here is I'm saying show database. Both of these are keywords, SQL keywords. And I'm saying show me all the current databases that are in MySQL. And I actually already have this because I already used the volume. So this was me testing to make sure that I knew what I was going to talk about tonight. So this FC, but let's look at well, we can look at this FSSE vehicle. So we're going to use FSSE vehicle, which I've already preloaded. You won't have that in yours. And what use means is saying, all right, we're selecting the database, because you can have multiple databases within MySQL. Databases are what they are, right? They're just collections of data, collections of tables. So in MySQL, there's databases and tables. Tables have columns, and columns and columns and rows, right? That's what a table is. Very flat structure. Think of it as an Excel spreadsheet. And so I can say show tables. Every single SQL statement needs to be terminated with a semicolon. Otherwise, it will just continue to the next line thinking it's all part of the same statement. So if you can ever figure out why your line's not running, add a semicolon. And you'll notice that I only have one table in there called vehicle. So I can say explain vehicle, and it will explain all of the different columns I have. Now, I don't mean this to make any sense to you guys right now. We'll actually design this in a bit. But you'll see some familiarity, right? Got some color from what JC did a couple weeks ago with the front end, right? Added some color. I added a few other things. There's the UID in there, right? And then we can select star from vehicle. Now, what did that just do? Well, select star means I'm going to select all the columns. These are columns. I want to select all the columns and all the rows from my vehicle table in database FSSE. So I've shorthanded because I'm using FSSE. I can also say FSSE vehicle dot vehicle because it's the database dot vehicle. So if you're actually selecting cross database, which you can, you'll have to namespace them like that. But assuming we're using FSSE vehicle, we're going to do that. You can select it, and I already have 3 records in there. Let's make these a little more readable. So instead of semicolon, I'm going to say \G, which just allows us to print them a little better. And we're good to go. So we got this first one. You'll notice there's a Ford Focus. Name's Dearborn. And we got a Honda Civic Tokyo. And we've got a Bolt Chevrolet Detroit. A few other things. Let's say we want to select all of the vehicles with a certain model number. Select star, meaning all columns, from vehicle where model equals bolt. Not gonna work? Yeah. And so we selected only one record, right? This one, by simply doing a where statement. We can also, do our other stuff where ID is greater than 2. So we should get 2 because ID is 1, 2, and 3. Or we can select the UID. Now you might say, geez, what's going on there? Well, you'll notice, what is that? That doesn't look like a UID. Well, we'll see why that is in a bit. But that actually is a UID. It's just encoded in hex, but you'll see why that is. We can explain vehicle again and see all the data types. This is where we're starting to think about data types for our data. We're just going to need to do that. Still kind of a carryover from the old days, but it's also very good because you can manage the lengths and everything. So that's kind of MySQL in a nutshell. Relational databases. They all kind of look like this. They all behave similarly in the context of this. It's the details that are different. So we like MySQL. I like MySQL for a couple of reasons. Number one, it's open source. But number two, enterprises tend to like it because Oracle owns it, and which means you can get enterprise support for MySQL if you pay the money. But it's also open source. So we use a ton of MySQL. In fact, that's kind of the only, if we need to do a relational database, we use MySQL. I've scaled MySQL to petabytes. It works. Yeah, it's not easy, but it works. You can get it to work. The other thing you might say, all right, are there any other reasons why you use MySQL? It really comes down to comfort level. I understand SQL really well. A lot of experience with it. I kind of know the ins and outs and the idiosyncrasies of little things you got to do with it in order to do performance tuning and things like that. So it really comes down to comfort level. A lot of people are diehard Postgres. You hear a lot of Postgres. Postgres doesn't scale very well in my experience. I've used it somewhat. You kind of hit a wall when you hit large data, hundreds of terabytes. So I tend to gravitate towards MySQL to start. And then there's a few others, but Oracle, if you want to pay millions of dollars for an implementation, and then there's IBM Technologies, same deal, but no one ever got fired for hiring IBM, right? So it just depends on who you work for. So if you get the freedom to choose, then I would probably choose one of the open source technologies. So that's kind of why we use MySQL. It's more of a comfort and experience level thing. You'll find others that do something else. All right, so I'm going to exit out of MySQL. Now let's check out Mongo. If we go over here, we're going to do the same thing. Now Mongo, you'll notice for MySQL we had to put a username or password. For Mongo, we don't. That's not good, right? Well, you'll hear about ransomware. Everyone knows what ransomware is, right? One of the most popular attacks that all the script kiddies do is they like to look for open Mongo implementations, because Mongo by default does not use a username or password, and they probably chose that in order to make it really super simple to use. So high adoption, right? Make it so easy to set up and use, but you pay for it in security. So a very popular ransomware attack is to go in, script kiddies search for all these open Mongo instances because they all know the default port and installed, and if you don't secure it automatically, which is easy to do if you're just kind of running it, then they can go in, capture all the data, roll it up, and then put a little note in the database that says, I have your data, just pay Bitcoin to this address. And so that happens quite frequently with Mongo. So be aware of that. Please secure your Mongo databases. I didn't secure this because these are all local. All right, so there we are. We're into Mongo right now, and we've got DB. DB is lists all of the databases that are currently in Mongo. So Mongo's language is a bit different than MySQL. In Mongo, instead of, you still have databases, so you have multiple databases, but underneath database, that's where it all changes. So we have concept of collections. Collections are somewhat analogous to tables, but we don't call them tables because they're not flat necessarily. They're collections of documents. When we say documents, they're JSON documents actually. So we store JSON in Mongo. And so we might say db.test and yep. So we switch to tests, and then maybe we can say test.find. Test is not defined. Let me do this. So let's do Mongo define db. I don't know where my data went, so I gotta look this up. So I'm gonna say use MyDB. So this is a brand new database, MyDB, and then I'm going to db.mynewCollection insert one. And so I'm going to change this to db.data. So I'm creating a new collection called data. So there's no, it's pretty interesting, right? Like I never said to create, there's no command to create a new collection or anything. It's all kind of implicit in this. And I'm going to insert one. I'm going to insert a document. And I'm going to insert hello world in this. And I think I'm going to insert Y, and then I'm going to insert yet another nested document. So Y and then F4. And I think I need to close that. Ooh, I was missing. I think I bit off too much there. All right. So I just insert x1 hello world as a document. It's acknowledged, and so I'm going to say db.data.find, which I'm going to find all the documents. So I inserted that document, and really there was no structure, right? I just kind of threw whatever the hell I wanted into it. And I'm going to insert another one. Hello, I'm going to insert x equals 2. And I'm going to say hello country, or Mars, and I'm going to say Y another object, and I'm going to say Y7. And why is that not?
Same name.
Did I not complete the? I don't know why it's not accepting that, but there we go. So now we can, so db.test.find, or db.data, that's my collection, .find, and you'll notice now that that I've got, two records in there. Now, if you think about it from a MySQL standpoint, I can't actually just create columns on the fly, right? I have to always fit my data into my predefined columns. But in Mongo, I can go and do this. I can say Y is equal to 8. I don't know why it does not want to accept that. It's so weird. So if I say db.find, you'll notice that these data structures, the structure is the same, but this third one is not the same because it has an additional data element in it. And so that means it's pretty flexible, right? I mean, with Mongo, we can basically put anything we want into this collection, and it can be totally different. All the different stuff, all the data can be totally random. There's really no structure to it. This is very powerful, but also very dangerous. There's no schema. So you have to be really, really deliberate about using Mongo. You'll see a lot of startups like Mongo, because it basically gives them carte blanche to not plan ahead. They can just start throwing data into it, right? Just design. Don't architect, just throw data into it and access it. Well, that's going to bite you in the ass real fast because it does not scale. And it does not version, cannot maintain. It's a real pain. So you can see how that can be very dangerous. So you have to be very, very careful. NoSQL database are exceptionally powerful, but very, very dangerous for the lazy developer and lazy architect. Don't let your developers, if you think they're lazy, don't let them use Mongo because it'll end very poorly for everybody. All right, so I feel like we're kind of done with Mongo there. Let's talk a little bit about Redis. Redis is very, very quick because there's not much to Redis, which is kind of the beauty of it. Also not automatically put with a username or password. In fact, Redis is very unique in that Redis does not have a user. You cannot specify a username. There's no concept of a username in Redis. There's only one user in Redis. And you might ask, well, how do you control that? Like, isn't it a database? Redis is designed specifically for speed. And by actually removing the requirement of defining a username, they actually take out a significant amount of access time. Now, you might say, how much time? A millisecond or less? A fraction of a millisecond? Yeah. But that's what Redis is about. Just doing things as efficiently as possible. And so by removing the username, you can really do it. Plus, Redis isn't really meant to be done on scale. So typically you move Redis as close to your data as possible, or as close to your application as possible, because you need that speed. So typically it either resides with your data in your own virtual private network and things like that. And so the security is a little less of a worry because you've already kind of structured it so that there's already an existing kind of firewall around it. So I went into Redis here, and Redis, and let's do Redis set key. So Redis is a very show you something here. All right, so Redis is really simple, very powerful but very simple. So let's say we want to say one other thing I'll mention. Redis also has a concept of databases, but it only has 9 databases. And labeled 0 through 9. There's no more than that. And the reason is so that they can do memory mapping and things like that. I love Redis. I think Redis is so cool. But it's only good for certain things, right? It's only so good for certain things. All right, so let's say set x. And we're going to set x to the value of my value. It says OK. Like the fastest thing ever. And then we can say get x. And that'll be my value. That's what Redis does. That is the extent of Redis. Now, there's some things like key scanning and stuff like that. But for the most part, you probably just use Redis like that. Gets and sets. Because you're putting one value and getting it back real fast. And you're probably overwriting it. There's a few other things. You can set X, my value, and you can put an expiration on it. So you can say, look, set X, my value, and keep it for 100 seconds. And then it'll disappear. That's pretty powerful too from a caching perspective, because you may know that your data will become stale after a certain amount of time. Then you can set it to become stale and leave your database. So there's a few cool things that don't necessarily exist in like a thing like Mongo or MySQL that Redis is really designed, and why I separate that idea of caching from relational and non-relational databases. You can also see that Redis is a non-relational database. Key value, right? It's kind of like Mongo. It's a key document kind of strategy. So you could put documents in the values. So all pretty straightforward. So
is that the whole depth of it? It's just database and then key value pairs.
Yep,
That's all there is.
Yeah, no hierarchy.
Is there no typing in there?
Nope, no typing.
Okay.
Just strings. Yep, no typing.
Is there always a string?
It may be. I'm not sure if it represents it. Yeah, I think they are strings because the keys are strings, and that's where key scanning comes into play. You have to be really careful when you start doing key scans because that's where your performance starts taking a hit. So you have to be really considerate of what you name your keys. So if you think about, this is a good conversation to have. So when you start to think about when you start to think about things like in the context of how does Redis find keys? So let's say you have like 1 million keys. right? That you're searching through. Well, what Redis does is it creates buckets of those keys.
Sorry, I
And,
don't understand.
and so when you create buckets of those keys, what you're doing is Redis is looking at the first few digits of first few characters of your key and saying, all right, of those, I'm going to start bucketing them together. And so what it can do is you can start doing hash bucket stuff or hash mapping stuff, where you can actually search, and if it gets bucketed, if the first few characters of the key is the same as like 10 others, then it'll put it in that bucket. And so you'll know to go to that bucket of those 10 in order to find the rest of your key. So you can kind of almost do a quicker search that way. And so, like a binary search type strategy. And so when what happens is if you don't come up with a consistent key naming strategy, you have to be kind of smart about it. You have to understand how Redis does its key scanning to find things quickly. If it's all over the place and random, so if you're like setting UIDs or something along those lines for your keys, then it's probably not a good thing. So because you don't really get advantage. So the idea is that you have to kind of bucket. You have to be smart about what you name your keys in order to bucket them together appropriately to maximize the performance. So there are little tricks and strategies that you can use on how you do keys and values. But yeah, Clayton, Redis is kind of, I think you'd get into Redis.
Is it, how big does it get? Is it limited in
It's,
keys?
yeah, so like managed, I don't know, you'd have to look it up, but the managed service, Redis services that I've seen, you'll see like the entry level, like 100 megabytes of space. So you'll notice that Redis is really not designed to store significant amounts of data. That's really not their jam, right? You can get, I've seen managed like Azure Cache, which is a Redis implementation. You can buy like 8 gigabyte databases and stuff. But eight gigabytes, I mean, it sounds big, but it's not, right?
I wonder at what level where it would be more efficient to use Redis than to use like a Python dictionary, for a small few things, but then at some point it's gonna be way faster in Redis,
See, well, it all depends on, it's a good question. See, it all depends on memory, right? It's always going to be faster to run things out of memory if you can. But the reason that you use something like Redis is because it's a distributed memory store. So if you're horizontally scaling all your applications that need to share a cache or share some quick access data,
same Redis
exactly,
implementation.
you have to use the same Redis backend to create that persistence that's consistent for everyone.
Okay, that's really cool. Okay.
Yeah, so Redis is all about distributed systems.
Got it.
And managing that. But to your point, if you only have one system that's using it, it's always faster to just keep that in memory if you can.
Yeah. No, that makes sense. I'm gonna have to check that out.
Redis is cool. Redis is cool.
Now, for the value side, are all values stored as or interpreted as UTF-8 strings?
That is something that I'd have to look up. Redis value types. Strings, hashes, lists, and sets, and sorted sets. So you can actually do, looks like you can actually do some data typing in the values. For the most part, you pretty much do this. You could do hashes. That's JSON automatically gets mapped to it. Don't use lists. Lists tend to get really slow. I usually try to just put strings in there. The only reason that you would put these things if you need to actually search your values, so this is kind of an effort to make Redis a little bit more attractive to normal databasing strategies. Typically you wouldn't use Redis. Typically you're just shoving values in without any intention of ever needing to search over the values. If you need to search values, then you probably are better off using a database like a MySQL or a Mongo or something like that, indexing, because you don't have the power of indexing within Redis values that you would have in in a MySQL or a Mongo. So yeah, you can store the values as different value types, but yeah, it's you can read all about it here. but it's beautifully simple. I really enjoy Redis, but it's good for very few things. So don't go crazy with it. Pretty lightweight too, so might be something to consider. It gets loaded into memory, so that's how they increase speed on it. It might be something to consider from an embedded standpoint. Right. So there's our 3 databases. We're going to integrate these into our backend now, but let's take a break, and then we'll spend the rest of the time doing that. Any questions before we break?
Oh, yeah, maybe it's just I don't understand the databases yet. So how do you feed in an image? We talked about all type of data, right? So how an image will be defined?
That's a great question. I think you do understand databases. That's a great question, and you'll hear a lot of different people debate where do you store images. You can store them like in MySQL. You can store them in a blob data type in MySQL if you want. I don't like to do that, and I think that a lot of people don't like to do that. It's hard to see them, right? Because it's just data that's shoved into a column. And it's kind of hard to search it and all that kind of different stuff. So typically, we'll use a NoSQL database or a non-relational database to store images. Does anyone know what non-relational database we typically store images in? It's the oldest of all databases. It's just a file system. It's Amazon S3 is a very popular simple storage. A very popular system, buckets, right, to store your images in, flat data. That is actually a non-relational database if you think about it, right? Key value, the file name and the file. That is a non-relational database if we're being strict about the definition. And so typically what you'll see is where you store images, videos, media, any kind of content type stuff. You'll see them stored in that type of situation. In a file system, that's basically served up by a file server, the age-old server, right? File server that gives you a URL to that file. And then you download that file from that direct space. In fact, a lot of cold storage, oftentimes, particularly like Mongo data, isn't stored in Mongo. What it does is they just push it. They basically create JSON files and then store them in like S3 or some file system, and then you can browse it like any folder structure or whatever. So, yep, good question. Anything else? All right, cool. I will see you guys back here at 10. I need to talk to Eric about something. So 10 minutes. Eric, you there? Answer that question. Oh well. Sorry, Reef. That question is lost to time. It is not recorded. I should have stuck all the things I probably said wrong into that, 5 seconds, so like someone can't get me on everything I said wrong. All right, so here's what I got. I created a projects folder, so I'm in my dev environment, right? Development environment. Everyone's got theirs working. Yes. In our development environment, and I'm going to clone week 4 into there. So I'm just going to go back here.
And I'll go screen.
Oh, oops. Good call. Thanks. All right, so we got this. I created a projects folder, and I'm just going to in my development environment. So I'm going to go over here, and I am going to look for week 4. So the stuff we did, I'm going to just clone it in. Git clone week 4. All right, good to go. And for now, let's cd space in the cloud here. And all right. So let's look at index. If you remember last week, we added some open API stuff, right? All that kind of good stuff. So some JSON schemas. We're going to see why those are even more important now from a database perspective, because there's a lot of database security stuff you got to worry about now at this point. So those schemas start to really be critical. We'll start doing real stuff in our route handlers. But first, we need to add a few things. The big thing here is we first need to do thinking we do MySQL. All right, so first thing first, right? Like I said earlier, you always kind of start whenever you're designing a system from scratch. I always recommend starting it from starting from the data model. So what I'm going to do is I'm going to create a folder called data in cloud, because we're going to be working in cloud. Because remember, we got our 4 parts of our system. We got our cloud, we have our embedded, we have our client, and then we have our front end, which is our client also. We're going to do not as much front end today. We're going to focus mainly on the cloud, and we'll bring in the embedded and the client too, just to keep things going and do some testing. But really, we're starting now inside of our cloud, our Node JS, to really start to think about how do we organize a good backend structure. And when I say organize, what does that mean? Just where your files and your folders are in your backend structure. There's a lot of different ways to do it. You'll see a lot of people. You see a lot of articles, like Medium articles and stuff, of people suggesting their best practice for boilerplate and structuring their Express applications and stuff like that. My belief, and generally what we do at Technicity and Modesto, is just keep it simple, really simple. And typically we follow a pattern. And I'm not saying this pattern is the best way to do it. We've evolved over the years. We've done many different ways. But we found that generally, if everyone kind of follows the same pattern, it's really easy to jump into someone else's project and help maintain or help add. And you just kind of, it's just normal, right? Like you just feel at home immediately. There's not that constant boot up of trying to figure out, oh, like, what did he do? Like, where is this stuff? Why is this abstracted this way? Like, we're all pretty consistent in how we do that. One of the advantages of educating all of you in this specific way is that you guys can jump right in, because I'm teaching you. By no means is it the right way. I've seen it a million different ways. You can even download whole project of just structured boilerplate Express apps that you can plug in and plug out. Those are cool. I mean, I don't have anything against them. It's just another thing to have to learn and get familiar with. So kind of pick your horse, right? So you just kind of go. So this is where we start to, the reason I kind of went on that soapbox is because this is where we start to structure our things a little better. We kind of did it last week with this middleware folder. And so today I'm adding another folder called data. And this is how we structure all of our stuff at Technicity. So, and Modesto. So we got new data, or new file. I'm going to call it data-model.sql. So this is a .sql. This is a SQL file. So we're out of JavaScript land. We're out of Python. We're now doing yet another language, just what you wanted, right? Right when you felt like, oh man, I know Node and Python. Now I have to learn another language. Well, fortunately for you, I can't say that I know SQL that well. And I freaking hate SQL. I know enough to be dangerous on SQL along with everyone else. I'm not sure there's very many people that know SQL really well. You know enough to be dangerous and access your data and insert data. And you figure out by reading Stack Overflow on how to get better performance when you need it, kind of thing. Don't optimize up front, right? Just get it to work first, optimize later. So, the other thing that we do typically is a lot of copy and pasting at this point. So I'm actually going to do a lot of copy and pasting. I always go to an old project because at one point, probably 5 or 6 years ago, like literally after this time, I did a data model, and we've just kind of used this data model structure since then. So I'm going to copy and paste from another database, another data model that I have here on my screen. And you'll notice that there's about 5 lines here. I'll go through each one. So this is drop database if it exists, FSSE vehicle. What does that mean? Well, if I'm loading in the new database, I want to drop the existing one. So if one already exists, I want to totally wipe it out and load in the new one. This is pretty dangerous, right? If you have like real data in there, you don't want to run this file because that means you're dropping your entire database. Drop means delete. It's gone. So, but in our case, we don't really care. This is also kind of a startup kind of thing. So this is fine. The reason we do that right there is for test purposes. Because oftentimes we'll have test fixtures, or that, remember we were doing Mocha in like week 2, we will actually write in a drop database and run this specific file every time. So you can start from scratch and run your data from scratch. So you know that, hey, you're setting it up right, you're running it, and you've got the full kind of tool chain that you're doing all the way through. All right, so you've got drop database, and then I'm going to create the database again. So I've dropped it if it exists. I'm going to create a new one. So create database if it doesn't exist, called FSSE vehicle. A little bit redundant there. If it doesn't exist, well, it's not going to because I just dropped it. But a little bit of, I guess, pedagogy there. And then I'm setting a few things about that vehicle, that database. The default character set's UTF-8. Pretty standard now, but you can see some legacy stuff starting to shine through already with MySQL. You got to actually set your encodings. You can do Latin 1, stuff like that. And then collate on UTF-8 general. And then we're going to use it. So everything else in this file, SQL is very linear, very serial. So every line after this line is going to be run, and we're going to use FSSE. So that allows us to not have to namespace and prefix all of our tables. We're just going to assume that any table we write is going to go into this FSSE vehicle database. All right, so let's create a new table and save some time here. We're going to drop the table if it exists. We're going to create a new table called vehicle. You're going to start seeing some stylistic patterns emerge here. One pattern is I always capitalize the name of tables. And then I'm going to camel case them too. So that's kind of stylistically how I like to do it. And then I'm going to drop table if it exists, and I'm going to create a table if it doesn't exist. And I'm going to create vehicle. And then I am going to start defining the columns in there. So this is the way we kind of do it. Every table I create in MySQL, I always add an ID column, and it's always an integer, specifically of type big int. So a big int is like 128 bits, I believe, which is the maximum that can be represented, or maybe it's 64 bits. Something. It's the maximum that can be represented. I think it's maybe it's 64 bytes, I think, a big int. So it's a really, really huge integer as opposed to just a regular integer. And that's if you have trillions or quadrillions of IDs, you don't run into collision issues. Every table has an ID, and it's not null, so it always has to be set. And I want it to auto increment. And what does that mean? Well, auto increment basically means I don't actually have to set it. So when I insert, it will automatically just take the last value that was inserted and increase it by 1. There's other things you can do, like you can say auto increment by 2, so every time it'll multiply by 2. So there's other keywords you can do, but typically you don't do that. And now the next thing I'm going to do is I'm going to say UID, because remember, we actually have 2 IDs here, right? We have an ID, which is a number, and then we have a UID. And that UID is what we've been using this whole time. It's that 16 byte, well, it's 36 bytes, I think, actually 36 characters of that universal unique identifier, and of type binary, 36. Now, why did we make it binary? It's not null, and it's unique. We want to enforce it to be unique in the database. But why is it binary? Well, here's a performance thing. If we do strings, then you have to search strings in the database. Strings are a very slow thing to search on. Not very good to search on, generally. But binary is good, because then it can basically choose its most efficient way of searching and indexing and do it that way. So that's why we do binary. Now, you might have remembered, right, when I was when we were looking at that MySQL, and it was and we looked at that, and you saw that. Well, that's the binary representation of a UID. So it's a lot longer. It looks a lot longer because that's the hex representation, but that's why it looks like that. So we use binary there. For
BJ,
readability,
before you go on, does auto increment guarantee uniqueness? You know?
within the same database, it does.
Okay.
If you have a distributed MySQL,
Yeah.
it may not, but I would have to check on that.
Okay.
But I would
Now,
guess not.
Now, why wouldn't we just want to use the ID from the table rather than the UID?
That's a good question. Anyone have an answer to that while I create some other things here? Why would we do that? It just seems like a lot of boilerplate.
Well,
Doesn't the embedded won't know that information, right? You won't be able to uniquely identify who's giving you the data, so they won't be able to populate it properly.
Kind of. It does have to do with obfuscation and security. It does. The primary, so you're getting to the right place. The reason we do that is because you never want to expose your database details to a client, ever. There's a lot of information. If you know a lot about a database, there's a lot of things you can do to exploit it. And so by kind of obfuscating and using a UID, which is not unique to any kind of database, you can totally hide that you're using MySQL behind the scenes of your API to a client. If you have a public REST API, which are very common, you can totally hide the workings and the details, which means you can protect yourself against a lot of maybe knowledge base that someone could use. So like Mongo intentionally uses object IDs for their IDs, instead of auto increments, they'll automatically, and I didn't really call it out, but we'll see it in a bit. They use things called object IDs, which is another standard like a UID. It's like a 16-bit thing, or 24, I think, 24 characters. And oftentimes you can tell by looking for the object ID in an API if they're using Mongo. And if you can tell that, you can exploit some of the things like, hey, I know that Mongo most of the time is misconfigured. All right, well, let me see if I can poke around a little bit and see if I can find a way into their Mongo. And then, boom, you're in their Mongo, you're good to go. So you really never want to expose any of those details of your database. So that's kind of why we do that. The other reason that we use UIDs is because we use an ID for each of the different tables. But you can imagine that, and maybe, Clayton, this is what you were getting at a little bit. You can imagine that I have a vehicle and maybe a model table. Well, the ID is going to auto increment for that table, not necessarily for the model table. And so what you will actually have, an ID of a model being the same as an ID for a vehicle. And that's okay. Like that can coexist. That's not a problem. But it can be very confusing when you're accessing IDs and things from an API or an application layer. And so by using UIDs, while they're longer and they take up more memory, they're globally unique across all your tables. Guaranteed globally unique across all your tables. Guaranteed is a fuzzy word. But when with that, you can actually do a lot of distributed stuff, and you can have replica sets across. You can represent data across the world, and you can actually have very scalable data, knowing that that record has a very unique ID, and it's not an integer. Just kind of hard to replicate. So those are the two reasons why we use UIDs as opposed to IDs. on our tables. There is a performance hit, but I've determined that the performance hit doesn't outweigh the benefits of globally distribution of your data table uniqueness and the security element of that. And we've done things like put binary here. I'm doing varchar here just for just to make it a little bit easier. Varchar is like a string, and it's we'll do varchar 50 name model. I'm going to copy and paste the rest of these in because these are just straight from the fields that we were doing before. Got make, model, VIN, year, description, color, color RGB, and image. A few things here. Text. You might ask, why did I use varchar versus text? Why isn't everything text? Well, text is not searchable very well. It's not as performant from a searchability standpoint. Varchar is far more performant, and it's also not as long. You'll notice that I'm only allowing 50 characters here because I know a VIN, actually I could probably limit that to 19, right? Because I think VINs are 19 digits. So I could limit that there. These are just kind of padded for no better reason. And then a description, I will rarely have to search in description. It's more of a metadata tag or just a data tag. So I'm going to choose text for that. So I just want to dump data in there, and I don't want to limit the length. And you'll also notice that MySQL has a data type called JSON, and there are methods to search JSON that is searchable, things like that. Not as performant as you'd like, but it's there. You can do strategies with that. This is where your MySQL relational database can become a non-relational database for you if you want it to be, as you can imagine. And I'm basically going to store color RGB into a JSON field in MySQL. So I'm kind of mixing relational and non-relational. I could have just as easily structured this to be color R, color G, color B, all integers. I've chosen this because, well, it's a little bit easier, and you will never split those things up. And I will never need to search those things individually. There's really no reason. So I might as well just put them together because, well, that's what they are. And I'm going to represent them in my API that way too anyways. And here you go, Ariv. This is to your question. How do we store images? Well, I'm storing it as an image URL because I'm going to store it somewhere else on the web, like an S3 bucket or on my own file server or something like that. I'm not actually going to shove the bits and bytes. You can shove base64 encoded image into a field if you want. Typically, I would recommend against that. All right, and then there's a couple other things I always add to tables. One of them is a created record. So you might say, well, doesn't MySQL keep track of that for you? Nope, you got to keep track. You have to do that if you want it. So we always do this, and I'm going to make it timestamp, not null. Timestamp's that epoch timestamp. And I'm going to make the default current timestamp. You might be like, wait, what's going on there? Well, what we're saying here is it's never null, but I want MySQL to take care of setting that current timestamp. Like I don't want to have to set that every single time in my code. That'll get really messy. I mean, I'm constantly doing that. I don't want to have to do that all the time. So one of the things I want to do is I want MySQL to do that. And so I'm saying, look, I never want it to be null, but if I don't set it, I want MySQL to just by default set it to the current timestamp. And current timestamp's a keyword in MySQL. And then I also want a record or a column called updated. Same deal. It's a timestamp. It can be null because a record may not be updated, right? It could just be created. And I want the default to be the current timestamp. And on update, I want it to be the current timestamp. So this is where SQL starts getting a little ugly. So all we're saying here is default, I want it to be the current timestamp, and I only want it to trigger, this is what a trigger is, this on an update, I want it to set it to current timestamp. So that means every time I do an update to a row of anything in any column, it will automatically put the updated timestamp of when it happened into this updated column. Pretty straightforward. Then I'm going to do a primary. Yep.
Quick question.
Sure. What's up?
timestamp, is time is a local time or what time zone the SQL will determine the
Ah,
time zone by?
great question. Time zones and databases are it's a shit show, to put it lightly. You have to make sure that when you install your database, that you set the appropriate time zone, and when you're writing to your database, it's an appropriate. You understand what time zone your database is in, or if you're getting data from it, it's coming back. That's why we like epoch timestamps or Unix timestamps. It's the number of seconds since 1969, 1970, midnight, or June 1st, January 1st, whatever, right? That way, we just put an integer in. That's our time. The client can handle it how it is. We don't, it's whatever. These created and updated, these are really record keeping, right? Now, that's why I call these timestamps and not date time, because MySQL has a significant library set for date time functions and things, very powerful. That's where time zone starts to matter. If you say timestamp, it's just going to put that epoch timestamp. It's time zoneless. That's the hope. But yes, it is a total shit show. Time zones are awful. All
So the
software developers hate time zones.
location need to be added, or it's a part of information, so that this will be useful to determine the time zone or something like that.
How do you set the time zone?
Yeah, I mean, so the location is needed here or not needed?
Oh, not here because we're using timestamp. That's a Unix timestamp. But where you set the time zone of the MySQL instance, so you can't. So you can set the time zone. Like you can easily set this to be like a date time, like a date time type. But then you have to specify the time zone in the string when you set it. Otherwise, if you don't set the time zone, then it will assume the time zone of the server and the installation of MySQL, which is kind of all over the place. You don't really know. They don't all default to UTC. I wish they did, but they don't. Sometimes they're in Central, sometimes they're in Eastern time. Who knows, right? Sometimes they're in India time. Like it just depends on where it's at, and who knows, right? So you got to be kind of careful about it. So in this case, it's just timestamp. So, all right. Simon, did you have a question?
Yeah, a short one. For the UID, you are setting it as unique. So is it for MySQL to verify that it is unique every time?
Exactly. MySQL will verify and it'll error if it's not. So if you accidentally try to set it, that's why. So we're putting a little check in there for ourselves. Plus, it's probably good to do. The other thing this unique does is it gives you an index automatically. So instead of specifying, and you could say index here too, but the uniqueness is implicit. There's an index there, and there has to be an index, right? Because it has to be able to check if it's unique. In order to do that efficiently, it would need to have to index that. So it's kind of a twofer. I actually do it more for the index than I do for the uniqueness, but you might as well do it for both. So moving on, every single table needs a primary key. If a table doesn't have a primary key, it'll fail. And this has to do with indexing. Every table needs to be able to be indexed. So you need at least one index on every table. And what we call that index is primary key. Now you could take an entire semester about relational calculus and all this kind of crap and what primary keys mean and all this kind of stuff. It's really just what is the most important thing that's going to be unique. Primary keys have to be unique in your table. What do we track? In our case, we always track the ID. So primary key, we're gonna name it ID PK, ID underscore PK. It's like a variable primary key. You don't actually have to name it. We do, and we're going to name it. We're going to reference ID, which references this guy up here. You could just as easily do UID and those types of things. We've already indexed UID. It's better to index the ID because you can do foreign key constraints and joins and stuff a lot more efficiently if you do numeric IDs as opposed to strings. So there's a little bit of optimization there that we're doing. I don't expect you guys to really, internalize what I just said there. It'll become more clear as you do more of this stuff.
And that ID, it says it's a big integer and not null. So by default, does it start off with 1?
1 or 0? I think it starts off with 1.
Okay.
Yeah, in fact, we actually, yes, I can verify that it does. Starts at 1 because I did that here.
Okay.
We can explain a vehicle. So I've actually already loaded this in. ID, big int, primary key, default, auto increment. There you go. And the first record in this table is 1. So it starts at 1, not 0. You could easily set 1 to 0 if you wanted to. But if you try to insert an ID that has an ID of the same number already in the table, it will fail because it's a primary key. All right, and then there's some other stuff. The engine we're going to use, this is MySQL stuff. I'm going to use MyAsm, and the reason is because there's better partitioning, a little faster for larger data sets. The most common one that you will see is in a DB. Don't worry so much about those things. That's kind of really advanced DB stuff, but like database administrators kind of geek out on that stuff. I don't tend to geek out. Honestly, guys, I'm not a huge database guy. Like I've come to respect it and I've come to know it, but not because I like it, but because I've had to. It's probably my least favorite part of the full stack stuff, honestly. That's a preference. You know, people spend their entire lives being database administrators and love it. So it really just depends on what you like. All right, so there's my database. All right, so if I'm in cloud now, right here, let's load this file and make sure that it actually works. This is relatively easy. MySQL-u-p root-h MySQL, and then I'm going to caret, meaning I'm going to shove the file data and data model into MySQL. And what that's going to do is it's going to take this file and it's going to drop the existing database, create it again, drop this table if it exists, which it won't because it dropped the database, and create the table vehicle. Assuming that I don't have any syntax errors. Oh, syntax error. So there's an error on line 9. I have an error in MySQL. It's very common. Good call. Thank you. Nope, that's not it. Thanks. That one. That worked. Nice. It also says warning using password on command line interface can be insecure. Yeah, never do that. I'm doing that because one, I'm lazy, and two, I'm in class. So don't do that. Do as I say, not as I do in this case. All right, so let's see. We've loaded our data. And if you notice now, we can go into it. We can use FSSE vehicle, and we can select star from vehicle, and it's empty, right? Because we cleared it all out, remember? There's nothing left in there, so that's fine. All right, so why don't we do something? Let's load this stuff up into code. Where do you think we should do this? Well, we created our vehicle. We only have one table. I haven't created multiple tables yet. We'll do that in a second when after we've explored our other databases. But where do you think we should do this at? What route? Anyone have any ideas?
Provision route?
Architectural. What's that?
Provision route?
Yeah, provision routes. So right here, instead of doing this thing, because remember we had an in-memory database, right? We based this was our database on line 29. This was our database. Man, if life was that simple, wouldn't it be great? It's not. We're going to get rid of this crap, and we're going to put in MySQL now. So this goes away. We got to replace this with a MySQL connector. All right. So how does that work? Well, how do you connect to that MySQL database? It kind of looks like magic, right? We got this cool thing here. We got a command line, but we need this code, Node.js, to connect to the database. Well, here's the beauty of the internet. It's all IP. MySQL, it's a TCP port. It's an IP port, and it runs on local host, right? Some server, and it's port 3306. That's the default. You'll notice I didn't enter any port. It's because the default is 3306. You can always change it. And in fact, you can change it. If you look here, I'll do something really cool. If you looked here, the ports I mapped 3310 to 3306. So that means on my local machine, my Mac, I should be able to access it on 33010. So let me do that. I've got a program here called Tables Plus, and Table Plus is great. Tables Plus, it is a paid thing. It is a paid product, but you can get a basically unlimited trial, and there's some limitations, but they're more just inconveniences than they are actual limits. So we tend to use it quite frequently, and so I'm going to connect to a new table here. So I'm going to look for a database. I'm going to add a database connection, new connection. I have a new MySQL database in class FSSE. I'm using 5.7. We're up to MySQL 8. The only reason I'm not using MySQL 8 is there's some different things in it, and I'm more comfortable in 5.7. A lot of our systems still run on 5.7. S8 was recently released. It's okay. But and then what port? 3310, right? And then root FSSE vehicle. And we got, let's test it. Ooh, it was denied. I wonder why that is. $33.10. I don't know why.
The configuration of the actual MySQL server. So the daemon has a list of hosts that it'll accept connections from. I've run into that before.
No, because I was just doing this earlier. It didn't have that issue. Well,
what port are you connecting to?
it's all right. It works here. Yeah, it works here. So I've got this vehicle, right? So I've connected this MySQL to this Tables Plus. I can Tables Plus. I like Tables Plus because you could connect to MySQL, you can connect to Mongo, you can connect to Redis, you can connect to just about anything. You can see all the different databases it does. I do lots of cool stuff in it. But you'll notice that there's nothing in here. Gives you a nice kind of structure, but you can kind of see this explain table, and you can see all of the stuff we just did, right? So it's pretty nice. And it also proves my point of it just being an IP address with a port. Now, it's not HTTP. It's its own MySQL SQL protocol that it's doing over TCP, but it is still MySQL. So you might say, all right, well, what is that protocol? Does that mean I have to write like in Node all that protocol to like pass that crap back and forth? Well, no. We're going to use a library. And we're going to go to NPM, our trusty NPM. Someone's already kind of done all the work for us. And we are going to use MySQL. And they've basically wrapped this protocol and given us some nice stuff where we can just pass SQL and get an answer back. So really, really good stuff. Problem is, with this library, it's got callbacks. And what do I mean by callbacks? It's got functions associated with it. So as parameters to this connection.query, we have to pass a function. And remember, we talked about promises and stuff like that. Well, this library does not have promises associated with it. So one thing that we can do, there's a couple things we can do. We can promisify this library. We can write a promise structure for it, which I'm going to do. Teachable moment. Or if you're like, screw that, I don't want to actually learn anything, you can go MySQL promises or promise MySQL, and someone did all the work for you. And they basically took that library I just showed you and wrapped it in promises. So now it's relatively easy. You can just use promises. But we're not going to do that. We're going to actually wrap it in promises ourselves. So a bit of a teachable moment. All right, so let's go to our cloud folder here. We got our data folder, and let's create a folder called lib. And what that stands for is library. You see these a lot. It's somewhat of an old kind of traditional thing. And what I'm going to create is a file in here called database.js. You could also create mysql.database.js or whatever. I'm going to actually put all of our database stuff in this file. So Mongo, Redis, and MySQL. All right, so we're good here. I'm going to now install, I'm going to npm install MySQL. I'm going to install that library I showed you so that then I can put it in. So I'm going to say const MySQL is equal to require MySQL. And what I can do here is I'm going to create a MySQL connection. Now I'm skipping a couple steps here. What is create pool? Because if we go to the documentation here, the first thing it says is create connection. And this is pretty standard, right? What we're saying here is we're creating a TCP connection to the database, which is just another program running on a server somewhere, right? Well, why am I doing a pool? Well, the reason is because I could do a connection here, that's fine, but that's not very scalable from an architecture perspective. With one change of a word from connection to pool, you get a lot of scalability. And the reason is because you can imagine, if you have tons of connections that are connecting to MySQL, this one database, and you're only creating one connection, every single route, every single thing in your application has to share that one connection. You're constantly opening and closing it. It's a very expensive thing to do. But instead, what if we could open multiple connections and share all these multiple connections and keep them open and just kind of lease them to the specific handlers that need them at the time? And that's what we call a database pool or a connection pool. And so when we say create pool, we're creating up to 10 connections or 6 connections or whatever it is. And what we can do is we can keep all those connections open to the database, and we can just kind of lease them out to whoever needs them at the time. And we can kind of parallelize the connections, the communications with the database with your application. So that's a pretty powerful sort of strategy that we can do and not bottleneck it by constantly having to open and close a connection. And if you can have multiple requests coming into your server, you can imagine that's pretty advantageous to be able to do. So that's why I'm using create pool here versus create connection. And then I'm going to copy and paste basically this stuff in here. The host is what? What is it, guys?
MySQL.
MySQL. What's user?
Root.
Password. Root. And what's the database?
FSSE vehicle.
Right. And then there's one other thing we can do here. with that pool, we can say connection limit. So we can say, oh, we'll allow a maximum of 10 connections to be created and maintained at any one point. And then we will assign const pool equal to mysql.createPool. Really good stuff. All right. So now we can use that pretty much anywhere, right? But let's do something else. Let's make this a little bit easier. So inside of our index.js file, we could import this connection, this pool connection all the time, and we can access it, right? Pretty easy. But architecturally, let's make this even simpler because we're going to have a lot of these calls potentially in our application. So why don't we just make one called query, like query. So we can just import query function, and then we just use that everywhere, right? In our application. So we're going to say module.exports. We're going to export.query is equal to a function, right? And let's say SQL and value. And then when we do that, we're going to just basically take this current pool and we're going to do a query here. And we're going to pass in SQL. And how do I know this? Well, I just read the documentation here. Connection.connect. We're already connecting because we're in a pool, so we don't have to actually do the connection. So here, what we're doing here is connection.query. So pool.query, we're passing in the SQL, and then we have to pass in a function here. So we need to SQL, and we need to basically do the value. That will become clear, and then we have to do a function for the results. So function, and we're going to do, if there's an error, it will put that as a parameter, the results of it, and then fields if we care about it, fields that were modified or returned. And we say if there's an error, and we're going to return basically the error. Otherwise, we're going to return the results. All right, cool. So we can basically import query now, into our index.js. Require lib database, and there's query right there. Unfortunately, this isn't really that convenient, and the reason is because if we do this down here, so let's comment that out because we don't need that anymore. And what we need to do is we need to insert, right? So if we say what this query is, there's an SQL, it accepts SQL and value. So SQL, we're going to insert something. Insert into, this is SQL. Insert into a vehicle, set something, right? We're going to set some values, specifically, or request.body actually. There's some magic happening there. Hang with me for a second before we get into the details of what's going on there. But the problem now is that values. The problem now is that we have to now do a function over here. We need to pass in that function. That's crap, right? Like now it's going to get muddy, and we're at this callback hell thing. So really, what we'd like to be able to do is we'd really like to just be able to do await. We'd like to be able to do result equals await query, right? And then we're done, right? And turn this into an async function up here, handler. It'd be great if we could do that. Well, but the problem is we need this thing, this function to return a promise. So how do we do that? Well, cool thing is we can use JavaScript and we can get it to actually return a promise. So how do we do that? Well, I'm going to say return new. We're going to create a new promise, and a new promise takes as a function that has two parameters. The first one is a resolve parameter and a reject parameter. And these are functions themselves. So what we can do here is we can say we can move this guy up into this promise. So we're returning a promise when this gets returned. And what we can do here is we're going to say SQL, the values that we want to search in SQL, and we're going to return. If there's an error, we're going to reject the error. Otherwise, we're going to resolve the error. So we're going to resolve the promise. Now that looks probably really freaking confusing, right? I mean, there is a bunch of stuff going on there. That's JavaScript all over the place. You're not going to get it right away. I promise. That's just the way it is. I want you to watch this over and over again. I want you to think about it. Ask me questions. Really think about it. Maybe do some of your own stuff and think that through. And it has to do with promises and features. Yep.
Quick question, Vijay. Where does the promise class come from after the new keyword? It just seems like it came out of nowhere.
It's built in. It's a built-in JavaScript function, or a JavaScript class, actually.
So it's like integrated into the language.
Yeah, it's built into the language. That's built into Node. Before, it actually wasn't. You actually had to import libraries and stuff for promises. It was kind of nasty. There's one called Bluebird. Great library, but they really included that in one of the later versions of Node now. So you can just use this promise. So really, we're just doing this promise so that we can very easily resolve the promise so that we can go into our index here and use this await query. Really, that's what this promise MySQL did, was they just went through and they wrapped all of these functions with promises. That's all they did. There's also a function called promisefy that will automatically go through and do it. We'll do that a little bit later with Mongo or Redis. All right, so we got this. So that's good. We've got, I got to plug in here. So we've got, so we got query. So here, now we might say, all right, if this is the case, how do I actually get errors into or get data into this thing? So I kind of glossed over that in the first place. Insert into vehicle. This is SQL. You just got another language to learn, right? But insert into vehicle set question mark. What does that mean? Well, this question mark, we could also do this. We could say UID equals UID equals rec.body.uid. We could do model equals rec.body.model, right? Because this is the request that data is coming in, and just build this SQL string up, right? Why do you never ever want to do that? This is really bad.
It doesn't scale if you're adding data, right? If you're trying to
Yeah. Oh yeah. The maintenance is bad on this because you got to do this. Plus you'll have it's nasty, right? Like you're constantly doing that. But there's a really critical reason why we don't do this. Anybody?
Would you have to put in model for body model?
No. Anyone ever heard of SQL injection? It's a security reason. SQL injection is really bad. Most libraries handle it now. You don't hear about it very much anymore, but it used to be a really big problem. So imagine with SQL injection attacks, this rec.body, we're basically allowing the client to send anything they want in this request.body, right? they could send in model. A model is just a string, right? They could send anything they wanted. And so a client could actually send SQL code in that body. And in fact, what they could do is this rec.body.uid, instead of actually sending a UID, or maybe rec.body.model is a better example. Instead of sending rec.body.model, what they could send is delete data from database. And that would be perfectly valid SQL, because that would return a table. So this thing could look like drop or delete star from vehicle. And delete star from vehicle returns a table, an empty table, because everything in SQL is a table. And modeled could equal a table. That's fine. It's a string with one column. Could even just delete ID. You can even say delete model from, and then it'll return a model. But what you're doing is you're deleting vehicles. So you're deleting it. So you can inject SQL just from the client, just an API sending it. That's really bad. Really, really bad, right? Because you can wipe out entire databases just by a simple API call. And so what we do to get around this is something called escaping. So, or cleaning, MySQL escapes. And what we can do is simply wrapping this thing into a string eliminates all that problem, because then it won't actually try to evaluate that string as SQL. So we could, if we wanted to, keep writing this and escape everything. There's also things like you want to escape, like you want to rip out special characters and things that might crash your database, things like that too. So you can escape everything with just quotes, and that's fine. But that gets really dirty really fast, basically to JT's point. And so instead what we do is we use the library that was provided to us, and this library has a really nice thing that allows us to right here. So basically allows us to put a question mark, and then any values that are provided in this values here will just be replaced by this question mark, but it provides a very critical service, and that is it automatically escapes those things. It's a very powerful thing. So it basically does all that work for us. We don't have to worry about it anymore. So from that perspective, that allows us to do this and do a rec.body. We can just pass these rec.body values, but we need to do one more thing, right? We need to put in a UID, and we also need to do something. We need to, let's see, we need to do a couple things. First of all, we need to rec.body.uid equals UID v4. Don't need that anymore. So now we have to kind of build this up, because remember, we need to set these default values, because if we go back to our database table, our vehicle table here, and explain, we have our UID, we got our name. So coming in off of that model, we can check our vehicle here. So we'd expect, nope, not in embedded, it's in client. Where is client? There it is. So we'd expect VIN to come in on that body, name, make, model, year, color RGB, and image URL. So that's coming in. Where am I? So that's coming in, but we don't get UID because that's on us, right? That's the server's responsibility to make the UID, not the client's responsibility to make the UID. So we need to put the UID on this rec.body. And then what we also have to do is we have to rec.body.color RGB. What's the problem with this color RGB? Anybody got an idea? Why do I have to mess with it? Why specifically that one is going to give us problems? You want to remember? It has to do with that MySQL data type of JSON. So you remember, explain vehicle. If you remember this explanation, remember this color RGB is JSON, but it's coming in as an object, right? Because it's a JSON object. So it's coming in as a JSON object. Well, MySQL library that we're using can't accept a JSON object. What we need to do is we need to stringify it, because MySQL expects that thing to come in as a string. It'll store it as JSON, but it expects you to provide it to MySQL as a string. And so what we need to do here is we need to say JSON dot stringify rec.body dot color RGB. Now this JSON is a built-in node, just like that promise. It's built in. Don't have to import it or anything. And the dot stringify. So it basically takes it and makes a string out of it, and then we can put it in there, which allows us to set this rec.body. Pretty cool, right? And then at this point, we can just return rec.body because we've modified it, inserted it, and then we can return it back to the client. One thing I'll mention here is that this question mark and this rec.body, this is an object. The beauty of this library also will map this rec.body, all the fields of this rec.body, into key value pairs in the SQL. So it'll actually generate escaped SQL for us automatically. It's a pretty powerful thing.
Only for the fields defined in the table?
Only, no. The fields that are defined in the object, this rec.body.
Oh, okay.
Yeah, but you're actually leading into my next point, which is good.
Why did we include the table dot, the table that you used manually, right? You logged in manually into this.
What was that?
So we have a table. You have a table dot. I don't know. I forgot the name of it.
Vehicle, right?
Application that you opened it manually, right? And connected through home to TCP/IP. So how did we include that here?
Oh, yeah, good question. How did we actually know to open that database? Not the table, but the database. The table is this vehicle. It's the database. How did we know to open it? We opened it via this create pool with these credentials. So this method right here, this MySQL.create pool, is actually opening all those connections. And then we're actually using this pool connection to query, and we're exporting it in this query function, which then we're importing into our index to where we can just use it. So it's all kind of happening under the hood in that. And there's a concept of function scoping, which we haven't really talked a lot about yet in most languages, but it has to do with the ability to scope variables inside of functions, right? So variables that are scoped outside of functions go into functions. We covered a lot actually in the prep videos and stuff, and you'll see it more and more as we go, and in office hours, stuff like that, we've covered it. But that's really how it knew to connect to that database. Is we basically set it up, and why we're actually separating and organizing our code this way to make it a little bit cleaner here, so we don't have to deal with all that stuff, all that boilerplate, which you're going to do over and over and over again, right? So to Clayton's point, does it only map the ones that are in the table? Well, it doesn't really know which ones are. It's not that smart. It doesn't know like, oh, I only need these in the column, because we're doing direct SQL here. You could use something called an ORM, an object relational mapping, that creates an object for you, and then you can reference the object, and then it's a little bit smarter about how it does it. But I don't like that. I think I like more having my hands directly with SQL, because as systems scale, those libraries and things that add a lot of boilerplate and nicety to stuff end up getting in your way. They end up slowing you down and stuff like that. So that's why I just write SQL first. But the issue here is that, let's say this rec.body had additional fields in it, right, that were not actually in your table. Well, it's going to fail. What that means is that it's important that we enforce the rec.body coming in to only allow the certain fields in a specific format. And what do we use for that? Anybody?
Schema.
What's that?
The schema.
Yeah, JSON schemas. Stuff we went over last week, right? So you see how this is building, right? That's how we enforce that. You see these systems coming together, and why that middleware is so important in that. It really simplifies this, because now we don't have to do a bunch of checking and crap here. It's already kind of taken care of for us. We can be guaranteed that we're getting the thing that we need and we want. And that's why this we can use knowing that we're relatively safe in using that. It's not going to fail. We've already checked it. It's really clean. It's really nice lines of code. Most of, like, I would say, what, Justin, 80% of your handlers in your function, in your applications, pretty much look like this. It's like a little bit of stuff, database call, done. Really simple.
Yeah, it's gotten to the point where really the bulk of the work for setting up the backend is defining the data model and then setting up the schema, right? And it beyond that, we'll get into it here soon, is setting up permissions, right?
Yeah, that's next week. So that's API security stuff. But you can generate most of this too, right? Now you can start introspectively looking into, and this is what, honestly, we don't do a lot of this. We have tools that generate a lot of this for us. We introspectively look into the table, we can grab that stuff out and then generate a lot of this code for ourselves already, and then we go in and kind of modify it from there. So there's a lot of power to this, doing it in this way. All right, so we have this insert into, we don't even really use this result because we're just inserting. So let's see if this works. The only way to really see if this works is to go to our client, right? So cd space client. We're going to create our virtual environment. I'm going to activate it. We're going to pip install our dependencies. And then Python main. Let's see if it works. Not working because why? Anyone?
Not running.
Not running. Got to run your back end. All right, now we're running. Oh, busted. Something didn't work. Let's debug this. So, we've got a parse error. Not working. So, insert into vehicle set. So, it didn't like this right here. Why didn't like that? Probably had something to do with my... Probably had something to do with how I defined this problem.
It's your value versus values. Oh, wait. I thought it was value before.
It might have been. I just copy and pasted the right answer.
Okay, then I was going to say, I thought I saw value there.
Yep. That's what it was. Let's do that. Good catch. Which is usually what our libraries use. There it is. It worked. Got a 200. So if we go to our table here, and we refresh, we go to our data, we got our 3 vehicles, our Focus, Civic, and Bolt in our database. That easy. That's pretty powerful, right? That's pretty sweet. That's pretty sweet. All right, so we've got that going for us, and let's just do a few things here, kind of finish this out, and then we'll move on to the other databases. Let's do. Let's replace this one, right? This vehicle's vehicle ID. So relatively straightforward here. You can see how this is getting a little bit tedious, but by using this query dot, making this function, it makes it a lot easier, right? Because we don't have a lot of boilerplate. So our SQL, so we want to get a specific vehicle by a vehicle UID, not an ID. So what we're going to do here is SQL, and we're going to do a select star. And what does star mean? It means we're going to select all the columns from vehicle where UID equals something, and the value we're going to pass a rec.params.vehicle UID, which just comes from over here, right? And we're going to we're just going to return results. Why is that failing? You'll notice it's because the await keyword can only be used in an async function. So we need to go up here, and we need to make this handler an asynchronous function. So we're down at 9,500. So we should be able to get a vehicle UID here. I'm pretty confident this will work, so we're fine there. But I don't really have a test for this right now. We could pull up Mongo or Mocha and test it. But let's do this vehicles, because our embedded stuff actually does use this, right? Because that's how it actually loads the vehicles onto the network. So instead of doing all of this stuff, this actually gets simpler now, as it turns out, because we can do a let results equal query SQL select star from vehicle, and no values. Just we want to get everything in the database, right? In that table, everything in that table. Now, stylistically, here's where a lot of people will defer on how you name tables. I always name tables to represent the singular row representation, meaning a row is one vehicle. You could easily call this table vehicles because the table stores a number of rows, a number of vehicles. By convention, we always name the table the singular of the actual data that you're storing in it. All right, so we got that. We need to await. We need to async this, and then we need to return results. Spoiler alert, this isn't going to work, but let's do it anyways. So I've got my embedded thing here, my sumo ready to go here, and let's make sure the data is working. All right, I got my vehicles in here, and so let's start my vehicle. So Python vehicle, it's my embedded sumo. I need to export my sumo home. All right, but it failed. Why did it fail? Well, let's look in here. Got vehicle. Oh, look, it failed on this one right here, these colors. I wonder why it failed on those colors. What do you think? Anyone got any ideas? I see a Reeves head nodding. He's got it.
change the schema.
It's JSON, right?
So,
But it came out of the database as a string. So we need to remap it back to an object so that Python can pick it up again. So there's some stuff that we got to do here. We have to basically go through all of these results, and we need to basically fix that color RGB in there. Now, I'm going to do a little bit of architecture here. I'm going to do something called hydration. So we could very easily just do results.map and map through each one of these and return, a fixed amount of data. But I'd rather create a function called hydration, right? Because I want to hydrate. What I want to do is I want to fix each one of these records. But there may be other things that I need to fix about them. More importantly, I may need to add other things. Like I may need to add objects like model information or more things from other different tables. So I'm kind of planning ahead by making something called a hydrator, a vehicle hydrator. So I'm going to create a folder over here, and I'm going to, in lib, I'm going to call it hydrators. And I'm going to create a new file called a vehicle. So it's going to be a vehicle hydrator. And the vehicle hydrator, I'm just going to module.exports.hydrate vehicle and make it an async function just in case I might need to do something from a promise. I'm going to pass in a vehicle record coming from a database. That's the assumption. It's coming from a database. And I got a few different things I got to do. Got vehicle.uid. I'll make sure that it's a string. So vehicle.uid .toString may come in as binary, right? So I may want to fix that. The other thing I want to do is vehicle.color RGB. I need to parse that into an actual object. So I'm going to use that JSON built-in method, and I'm going to do parse vehicle.color RGB. And then I'm going to return the vehicle. What I'm really doing, that's kind of simple, but what I'm really doing is I'm setting myself up for the future because I can basically keep using this function everywhere that I need to hydrate my vehicle. When I say hydrate, I just mean add other data. So if I need to maybe hit another database route to get maybe a model or a make or other information about that vehicle, I can just do it inside this function. And it happens everywhere that I'm using this function. So a pretty powerful architectural thing. And so what I can say is hydrate vehicle, and what it did for me was it imported that hydrate vehicle. My IDE did that for me. That's why we use VS Code. And so what I can do is I can map through each one of these, and I can return hydrate vehicle of R. So I'm basically mapping through an array, results array, of all the vehicles that were returned, because I expect 3 out of this, right? Because there's three records in my database. So I expect 3 vehicles to come back, and I'm going to map through each one. I'm going to hydrate each one of them, and I'm going to say let hydrated results equals results. That's not that simple. We're in JavaScript, unfortunately. So each one of these, this is actually a promise. It returns a promise. So what we actually have to do is we got to promise.all each one of those. We need to await it. And then we need to return the hydrated results. JavaScript, guys, I'm sorry. I don't have to do it in Python, but got to do it in JavaScript. Actually, you do have to do it in Python if it's async await Python, which you should be using. But the this is why you have to do this. And we went over this in like office hours. There's a couple of videos and lots of other stuff. So once again, another one of those things. Read about it, look at it, try it out, and it'll become second nature eventually. So we're going to return hydrated results here. So let's see if that works. All right, it worked. So our vehicles are now running with MySQL as a backend database with all that information. Pretty sweet. But let's do this. Console.log hydrated results. Ooh, cannot read data of undefined. It looks like we've got an issue here. And the reason is because we're trying to do this, but we kind of started killing our in-memory database, right? We don't have an in-memory database anymore. And so when we're trying to put data up to the cloud, it doesn't exist. And so we're kind of all in at this point. We're going to have to now do more databasing like Mongo and Redis. All right, so if we want to do this, let's do Mongo next. So you might think, all right, so what can I use Mongo for? Well, really, there's one thing left. The answer is the data, right? The vehicle UID data route, where we're posting data from our embedded system. Could you do it in MySQL? Sure, you can store data in MySQL. In fact, we do it all the time. Is Mongo maybe more appropriate? Well, imagine you have 25 different vehicle models that are all reporting different data. You're trying to maintain all of that different stuff. And you need massive data. I mean, this is just terabytes of data potentially on a weekly basis you're collecting. Mongo might be the right option for that, because you might need the flexibility of Mongo and the big data aspects of Mongo that it kind of gives you. So in this case, let's say that we've chosen to use Mongo specifically for our data here. There's always, from an architecture perspective, there's always the question you have to ask yourself. Is it worth introducing yet another database technology into a system that we might say, well, MySQL is probably good enough? Chances are you probably want to stick with one database technology because it's going to simplify maintenance and everything. Plus, there's like, how do I find talent to maintain it and all that kind of stuff? Now you need like two people, one who's an expert in Mongo, one's an expert in MySQL to do it. You know, there's all that kind of stuff. So typically, you'll probably want to stick with one and go. I've done both. I've done big systems for enterprise that have two database technologies because they need it in order to scale. And you know, they have the money to afford. A startup, you're probably going to want to stick with one technology and ride that horse because you kind of need to, because you can't really afford to develop skill sets in both databases and all that kind of stuff. So from that perspective, let's pretend we're part of an enterprise. We have the bandwidth and the expertise. Let's use Mongo here. So we're getting rid of our little data push in-memory database here, and we're going to use Mongo. All right, well, Mongo, as it turns out, is just an IP, right? It's sitting on a server somewhere. It has an IP address and it has a port. I think it's like 127.0.1.2 or something is the default port for Mongo. And it uses its own little protocol, MongoDB protocol, to talk. Just like MySQL uses its own SQL protocol, MongoDB has its own little protocol it talks. And as it turns out, just like everything else, there's an npm MongoDB library. Sweet. So we can use this to start going. So we can basically use all of this stuff to go. So in our case, I'm going to go back to my database file, and I'm going to shove this. So we have MySQL, but I'm also now going to do Mongo. I'm going to copy and paste this in from here, and the URL, but I need to install Mongo first. npm install MongoDB, I think. Is that it? Yeah. All right, so that's installed. It's built, loaded. Seems to load up. That's good. And let's create our Mongo URL. MongoDB. You'll notice that looks a little bit weird. It's actually not. Just like we use http://, well, we're using MongoDB protocol. So that's pretty cool. And then we're using Mongo, which is our Docker container, and 017, which is the default. And the MongoDB name, since we're storing data, let's call it FSSE data or vehicle. Let's just call it FSSE vehicle, but it's really the data. Let Mongo, and then we will just Mongo connect. For the sake of time, I am going to copy and paste this, but I'll explain it. So we're going to this Mongo client that I've created, and I'm doing .connect, just like we do with that pool. There's not the same concept of pool connections. Mongo kind of handles it under the hood, but we're passing the Mongo URL here. This right here is to stop some deprecation warnings. Don't worry about what it is. Honestly, I don't even know what it really means. Use unified topology. It is some setting of something in Mongo, so you can read about it if you want. And then this is the function that runs once it gets connected. This is an asynchronous function. And then what I'm doing is I'm just assigning the client.db of the MongoDB name, FSSE vehicle, to this Mongo variable, which then we can create some functions. Just like we did this query, we can do the same thing with an insert document. So module.exports.insert document, and I'm going to insert the collection name, so just like table, and I'm going to insert the documents that so these are just two so this is a function that takes an object with two things, a collection name for Mongo and a list of documents, an array of documents. And I'm going to promisefy this because, as it turns out, MongoDB also does not have promises. And I'm going to, let's see, equal mongo.collection. How do I know this? Well, I read the documentation. And I'm going to pass in this collection name, which in our case it would be a FSSE vehicle. I'm going to assign that collection to C, and then I'm going to say into that collection I'm going to insert many documents. I'm going to insert my documents. So I'm basically setting this up. We may only ever insert one document, but I'm setting it up for the future to say we could also insert multiple documents at the same time if we need to. Otherwise, let's just insert one, which is an array of one. It kind of covers everything. And then same thing as MySQL, function results, and then I'm going to, if there's an error, I'm going to reject it. Reject the error so that it'll throw up the errors all the way up the stack, and then otherwise I'm going to return and resolve the results. So same thing as up here, just with Mongo using the Mongo library, which is insert many. And then I will also do the exact same thing for a find all. I'm just copying and pasting it for the sake of time here. But really what I'm saying here is same thing with this collection, c.find filter, and the filter is going to be basically our where clause, right? That we would use. So like where timestamp is greater than 1, or timestamp is greater than a certain time, or between. I can collect those. I can pass those filters in, and then I'm going to convert it to an array, and then I'm going to reject and resolve that result. So this is basically a select, an analogy of a select statement from MySQL, and the insert is the same as the insert document. All right, so I'm going to go back to my index, and I can insert document. I'm going to import it from my database and then find all. And we need to go down to our data here, and we need to insert document, and the collection is going to be the collection we'll say is vehicle data, the collection name, and the documents are going to be, what are the documents, guys? It's an array of what? Anybody?
Is it rec.body?
Yep, rec.body. Nice. But there's a few things we got to do first. The biggest one that we got to do is if we insert, we change this to vehicle UID. If we insert just data into, if we just insert rec.body into our Mongo database, it's just data. There's actually no identifier as to the vehicle, right? On that. It's just random speed. there's basically no identifier for it. So if you have multiple vehicles reporting data, which we do in our Sumo, you really don't have any clue, right, what data is later. So it's useless. So what we have to do here is simple thing to fix. We do rec.body.vehicle UID is equal to rec.params.vehicle UID, UID, which I changed up here. Now you might say, why don't you just include it in the body? I mean, you could. It's an architectural decision. I like to include the actual ID of the vehicle in the URL for logging purposes, as well as from an API perspective. It's a lot cleaner, I think. So it's kind of, once again, maybe not the right answer for everything, but that's the way I like to do it.
From a scaling perspective, BJ, is that something that you would do on a table-by-table basis? Like if you were really going to a large scale, would you just make a table by UID for an individual vehicle?
No, I'd still put it all in the same table. Yeah, that would end up being you'd have to automatically create tables on the fly, and you do not want to dynamically create tables because you don't have the power of index partitioning and everything. It's easier to manage performance on a table that you know you created than it is to manage index performance on dynamically created tables. It's not usually a good idea to dynamically create tables, persistent tables in a database. You can create like transition tables and stuff. You'll have to actually in order to do like joins and like crazy SQL stuff. But those are transition tables. They're ephemeral. They go away pretty quickly. You'd never want to create like a persistent kind of dynamic table. If you're starting to do that, then you probably are structuring your strategy wrong, your architecture wrong. You'd probably do that a little bit differently. So no, typically you want to, I mean, billions of rows in a table is getting on the relatively large sides. That's billions of rows though, right? That's a lot of stuff.
Yeah, I'm just thinking the concept of like we have where you're logging data from, fleets of vehicles for thousands of miles, millions of miles.
Right.
Overall that, it's relatively persistent to some extent, but
in that case, you probably want to consider Mongo because that you might create a collection per vehicle. That's where your collection management becomes a little bit different, and your things how you manage performance is a lot different. Indexing is a lot different. There's a lot of more automated index management. To Beth Ann's question on Mongo, Mongo does a lot more of that than MySQL does, and so you may want to consider things like Mongo for that, or like a time series DB or something that would be a better candidate for that type of thing. With that said, I really like relational databases because they really force you to structure. As you can see, Mongo, it really promotes laziness in a big way. It'll get the best of you. It gets the best of all of us when we get lazy really quick. You gotta get that thing out the door, whatever, and just add a field to that document. It won't hurt anyone, and then it ends up hurting everyone in the end.
Does Mongo allow you to enforce a schema when you're inserting or anything like that?
It does.
Okay.
And we won't go over much of that today, but it does. There are things. In fact, the MongoDB connector we don't actually use a lot. I use something called Mongoose, which is another library. Mongoose actually forces schemas, and then that way you kind of manage that. It also has promises and all this kind of stuff already associated with it. And what it does is it actually forces you to create a schema before you even connect to Mongo. So it's kind of trying to promote that better behavior. So there's a lot of different strategies in that. I'm just using the direct MongoDB kind of at fundamental right now. But you will use Mongo. If you use Mongo, you'll use Mongoose for NPM and like PyMongo for Python, stuff like that. That kind of forces that schema stuff because it's such a dangerous thing. All right, so yeah, we're gonna pass in rec.body. I'm doing something wrong here though, right? Apparently it doesn't like something. What doesn't it like? Oh, anyone see it? It's the async. And then we're not going to pass anything back here. In fact, we don't really even have to await this, right? Here's one little powerful thing about asynchronous programming. If we're putting data up really fast, I don't really care if the vehicle if this returns before I'm done inserting that document. In fact, I kind of want the vehicle to go as fast as possible, and so I want the vehicle to close that connection as fast as possible. So I actually don't care if this guy returns before I'm done inserting because I'm not depending on that. And so that's one of the nice things. I don't even have to really await this at all as a decision point. All right, so let's see if this works. We're posting data. That's good. Posting data. Let's see if we can look it up here in our databases. So I've already actually connected to one here. All right, so here is our data, our Mongo data. So I connected to it the same way I did the MySQL. I just gave it the right credentials. And you'll notice here's this object ID I mentioned before. Kind of looks like a UID, but it's not. It's an object ID, another standard. But you'll notice here's our distance, acceleration, position Y, the vehicle speed. Ooh, and the vehicle UIDs start showing up here because I actually tried to do it before and didn't add the vehicle UID. So you can see we're starting to add the vehicle UID. And let's see if we can keep adding. Let's see. So you'll notice 599 rows. It's currently running. You'll notice as I'm refreshing, that row count down here, it's going up because the simulation is running. That's pretty cool. So we are storing data in Mongo, driven from a MySQL vehicle stuff, kind of relational data. That's really cool. That's really cool. All right, so we've got that. We're almost there. Almost there. Now, we also have this concept of latest data, right? And the latest data shows up in our front end. And our front end, really all we care about is getting, if you view this kind of Mongo database as a bit of a stack, right? It's where you can push and pop. Because if you think about it, we're basically just pushing data onto this stack. And really it's first in, last out kind of thing. We're just keep pushing it, keep pushing it, keep pushing it. But we always want to pop that first one off the top because it's the latest data we really care about in most cases, whether it's on your app or another vehicle might need it or your analytics team might need it. It's that latest data. So it makes it really good from our kind of fictitious application we got going here. It's a really good candidate for a caching database, right? Because it's quick read, quick write, then I'm done with it. It's the latest data. Quick read, quick write, done. Out. That's pretty cool. So what we can do here is we can introduce Redis, right? For our latest data. So same thing, go back to NPM. Nice, someone did all the work for us. Redis, once again, TCP connection, IP, right? And I think the default port, it's like 6301 or something. Whatever it is, pretty standard. And it's really good. So let's install npm install Redis. We're installing Redis. We'll go to our database thing here. And we'll const Redis equals require Redis. And we're good to go there. And we've got, just following the directions here. So we have Mongo here, we got MySQL here. I'm gonna create a new Redis client. Connection refused. Why was the connection refused? Well, because it's trying to, by default, trying to hit localhost, right? Well, we need it to hit our Docker container. And so to do that, you gotta go read the documentation. Which I have over here. And it looks like it takes an object, this create client with host. We're just gonna say Redis. And we don't have any username or password. That connects great. And then we can create a couple of different things. We have module.exports. We have two functions that Redis provides for us, get and set, right? So let's do a get and set. .get. But if we look here, Redis also does not really do promises, but the great thing about these Redis developers is they've given us a really nice way to promisify everything, so we don't have to wrap all that promise crap. They've already told us kind of how to do that, and they've said, hey, you can import this promisify function, promisify, whatever. And what that does is it basically does all of this nonsense, this wrap new promise. It automatically does it to the library. And this util, we didn't npm install it. There's actually included in the node install, the node node v8, just like JSON or promise. So we'll go back here and we'll say const. What did I just do? Get, and I'm going to call it get cache. And you'll see that we can use promisify. I'm just copying and pasting from here. We can promisify the client, this guy, .get, this function .get, and we're going to bind it to the specific client. That's a JavaScript thing. We'll do the same thing for set. I won't get into what, binding objects and stuff together. Not today. Something for another day. And we got module to exports. All right, we can go back to our index here. We can do a get cache, set cache. So first thing we need to do in latest data. This is a get. We need to post latest data. We already have our schema here, which is good. So we're going to insert the document in Mongo, but we're also going to set the document in Redis in order to be picked off the top. Now you might say, well, why don't you just get it from Mongo? You could. But Mongo is really meant for really big data, and you're going to be doing a lot of thrashing with those IDs. So you're constantly going to be querying Mongo. So you're going to be inserting and querying really quick back again. And what you're creating is almost like a queuing system in your database. You never want to create a queuing system in Mongo or MySQL, because what you're doing is you're creating a thrashing type thing. And what that means is that you're writing really quick, it's writing the index, and then you're just asking for it right back. But because it's designed and it has a ton of data in it, you're actually having to do a find on that new record. You're constantly rebuilding indexes over and over and over. And so if you're doing that and you're always just asked for that top record, you're really doing a lot of work and you're slowing yourself down on this really large database. And so that's why we're saying, look, put it in Mongo, because we want to store it for good. But we also want to just put it on Redis really quick so that we can pop it off real quick again. So we're going to set the cache. We'll go over here. Let's look at, it looks like if we want to set it, it's the key and the value. So the key, let's make the key, what anyone have an idea? What should the key be in our Redis key value? Anybody?
Can you do the values from the schema?
You can do some of the values from the schema, yep. But think of it broader, like in a broader sense. When we want to get that data again, what data are we going to have to get that?
UID.
The UID, the vehicle UID, right? So maybe we should make our key the vehicle UID. Where do we get the vehicle UID come? rec.params.vehicle UID. And what do we want to do? Well, we want to JSON.stringify our rec.body. So we set the cache, right? And then down here, you can do the same thing. We'll just do get cache, and we just need to do rec.params.vehicle UID. This is the get version of this latest data, right? This is what our front end's getting. I could boot up the front end, but I'm just gonna hit it on the browser. So I don't need that anymore. And in fact, this is going to only be the latest data. I don't need a length. I basically just need to check if latest data exists, because I know that this library, if that key doesn't exist, it's going to return null. So that's falsy. So I can just return no data available, so that it's never reported before. There's no latest data. But in order to do this latest data, there's one thing I have to do. This latest data is a string, right? So what I have to do down here is I need to JSON.parse the latest data. You might say, man, that's a lot of processing. Isn't that slow? Yeah, kind of. It's constant time. It's really negligible in the end. Just the fact of using Redis is getting you a lot more for that. There's a lot of serialization and stuff that you're getting killed from anyways. That's the least of your problems, is this right here. All right, so let's run this. So we're running it, And we've got, let's pick a UID out here. That UID. And so we got a local host 9500 / vehicles / the UID, the vehicle UID / latest data. Ooh, something's wrong. Unexpected token. Oh, I see why. Anyone see why? JC, you see why? Well, before JC ends, I'll be impressed if anyone gets this. Now's your chance to impress me. You can get this. I'll give you a job right now. Time's up. Whew, I didn't have to get on a job. We got, problem is this get cash right here returns a promise. And the reason, and what it says here is that it can't parse JSON. So it's really complaining right here, right? It can't parse a promise because a promise isn't valid JSON string. So what we have to do is we have to say await async. And now that should work. So let's run this. There it is. Look at that. Coming from Redis. That latest data is getting updated. I'm just refreshing here. And I bet it left the simulation. Nope. It's just stopping. There it goes again. Pretty sweet. So, and it's being collected in Mongo here. There it goes. The rows are getting large, actually. Simulation's done. But there we go. So, MySQL, Mongo, and Redis. All databases in about 2.5 hours. 3 hours.
Not bad.
Not bad. There's one more additional thing I want to go over in MySQL, but any questions?
One thing I think it's a JavaScript thing, but might be good to elaborate on is you use the word falsy there for line 187. What does falsy mean versus false?
107?
Oh, sorry, it looked like an 8. Yeah, 107.
107. Yeah, falsy is kind of a nebulous term. When I say the word falsy in JavaScript, there's a significant amount of frustration in equality in JavaScript. It's a big knock on JavaScript. Equality is a very frustrating thing, and you actually have two different equality operators. One of them is a double equal sign, and then the other is a triple equal sign. Now, what's the difference? Well, a double equal sign is a general equality, object equality. And what that means is if I evaluate both of these values like on both sides to a string, then do they match? So does the string 1 equals the integer 1? Yes, right? That they do. Those two things are equal. If you want to really check equality, meaning strict equality comparison, you use a triple equal sign in JavaScript. And what that means is that you can check the string 1 does not equal numeric 1 because the types don't match. You always really want to use the triple equal sign because that's what's important. You don't really want to let JavaScript try to interpret what you mean. You never want to let machines try to interpret what you mean, right? And that's what you're kind of allowing a lot of JavaScript to do with double equal sign, triple equal sign. Which brings us to the word falsy. What does falsy mean? Well, falsy also implies there's a couple of different what we call like null types in JavaScript. There's null, there's undefined, and then there's true and false, right? False. So when I say falsy, what I'm saying is this latest data right here could be any one of false, they could be null, or it could be undefined. So that's what falsy means. If I actually say false, I mean it is literally Boolean false. But if I say it's falsy, it could be null, undefined, or false. That's a JavaScript thing. It makes it very frustrating. But it also, the double equal sign and triple equal sign goes into that too, because that double equal sign could equate to falsy, but a triple equal sign will always equate to true or false.
And I think what I had up there before we switched it over to using Redis was an array length check, right?
Yeah, you probably did.
Yeah, it was length and then -1.
So in that case, it was also a falsy type check, which is 0 would be considered false in some cases.
Let's look at that.
Oh, I'm sorry. Yeah, I think I put that in there on purpose, just not to confuse. So you can technically, like what's in there now with the exclamation point and then the variable name. I could have also just put exclamation point all data dot length.
Mm-hmm. Right here, those two things would have been equivalent.
Right, instead of saying it's equal to 0.
Mm-hmm. Yeah, I kind of skipped over that. That was a good point, JC. Little JavaScript things, unfortunately. Python's a little more clear in what it does. Other questions?
So instead of storing
database.js where you wrote the connection functions, you used new promise, whereas on this side, on the cloud side, you were using async. Well, those could also have been written as async and await. Could have been, or
this right here. Technically, you could. That's an interesting thought experiment. You wouldn't do that. But I guess technically you could do something like this.
no, I didn't expect you to do that. The only thing was, the office hours we went through. I do that kind of exercise. At one point, you think you understood it, and then maybe today again I confused myself as to when do we go for async function or we declare it as a promise and then await it.
Oh, I see. So like when do you actually put async await, right? And when we do a promise. Yeah, this is you won't do this very often. This thing right here.
Okay.
This is a I would say very rare case, and you're pretty much the only time you really do that is to bring like a legacy library up to using async await. Actually, going into this week, I struggled with whether or not I was actually going to do this in front of you, or if I would just make my own functions and put them here async await. Almost like that's how rare it is that you would do something like this. But I wanted to show you kind of what's going on under the hood. So if you ever have the question of do I use a new promise or async await, use async await. It's probably pretty rare that you would actually do this. And you really do that if you want to artificially create a promise. In this case, we are artificially creating a promise because we have to in order to promisify this callback. So that in our index.js, we can just await a get cache.
Understand. Yeah.
Yeah, and as an extra detail there, like any type of async function automatically returns a promise. You just don't see it explicitly stated. So if you put async at the front of a function and then you return something from it, it's equivalent to saying returning a new promise and then putting the answer inside of that resolve. And then the same deal for reject. If that async function throws some of an error, essentially that was like putting what was thrown inside of the reject.
Mm-hmm. Good point. They are equivalent, actually. So it's basically shorthand. Async await is basically shorthand for that new promise, kind of. Um, kind of. But you wouldn't, in the case of how we're doing in database.js, use an async await.
Yeah, the async await really helps kind of allow you to write your code in a linear manner, which is a lot easier to reason about.
Yeah. Yeah, if you try to, oh man, I can't tell you the number of hours I've wasted before async await trying to work out promise uh, promise callbacks and stuff and the logic and like seemingly simple things, but it's like, man, it's a brain, crazy brain.
I should start mixing the async awaits with promises in them, right?
Yeah, yeah. Sometimes we'll mix the dot ends in there, just to just to stick one to the next guy coming through.
I remember one time we were working on some. It was recursive searches over a tree, and we were having to write a recursive function along with promises, and that really throws you on.
Yeah, that's the big thing, recursive. Yeah. Oh man, the hours I've wasted trying to write recursive functions and promises. I don't even want to think about it. Reeve, did you have a question?
Yeah, so we are sending the Redis data to the cloud. Instead, is it possible? What's the difference between getting the data from Mongo itself rather than, because we are storing only the latest data, right? So we are sending in two locations rather than pulling data from the Mongo itself.
Right. So in this case, I mean, we're storing all the data in Mongo, right? But we're only storing the latest data in Redis. So per vehicle, there's really only one record in Redis, but in Mongo, there's n number of vehicle data, right? Records for a vehicle in Mongo. The reason we don't just pull it off of Mongo, the example's a bit contrived in our case because we don't have a lot of data, right? But in a real scaled situation, you wouldn't want to thrash Mongo like that because what you're doing is you're pushing a bunch of latest data for a lot of vehicles onto Mongo, who's really designed to, in our case, really designed to basically store tons of data and just keep pushing data onto it, and it's going to be indexing that, right, all the time. What's happened, what if you try to then go and request the latest data off Mongo for a number of vehicles at all the same time, you're actually thrashing that index over and over and over. You don't really want to do that. What you end up doing is you end up slowing down your writes to Mongo because it's spending a lot of time just reading just the top record because it's constantly just growing. It's constantly doing that. Now you can optimize those things, right? You can write your indices that way. You can even write collections. What I see a lot of people do is they actually have a latest data collection, and they'll just write the latest data in the collection and read that collection, and it's not going to affect your other stuff, right? In that case, you're still writing to two collections, right? Your history data and that. We've just chosen to use Redis because it's so freaking fast. It's so freaking cool too. But this is what it's really designed for. And honestly, you don't need a ton of data. Like it doesn't have to be big, right? That's kind of the beauty of it. Plus, with Redis distributed, you can do all that kind of stuff. You don't have to worry about scaling that with like Mongo. Scaling Mongo is an art. It is really, really hard. There's a concept called sharding, which is a very frustrating thing. I was brought in by a large cable company, it's a consulting company for cable companies for like Charter, Comcast, those cable companies, and their big problem was scaling Mongo, and I'm currently working on the project to figure out how to correctly, scale Mongo. Their problem is they didn't make the right decision up front, and so they eliminated their opportunity to shard. Sharding is a lot like partitioning. It's like analogous to partitioning a relational table. As it turns out, they didn't structure it right from the beginning, and they have terabytes of IP addresses that they literally can't shard now. And so like they basically screwed themselves from the beginning because whoever designed it didn't know Mongo. It didn't understand the intricacies of it. So you can really paint yourself into a corner with this kind of stuff. So given a choice, it's probably good to use Mongo as a big data store, one that you don't have to like thrash a lot, and use other things. So does that answer your question? Anything else? All right, well, we're at midnight. There was one thing I wanted to show. It's not critical. I wanted to show foreign key constraints and things in MySQL. I'm going to save that to the office hours. It's not going to take much time. It'll take 10, 15 minutes. I'll introduce that during the office hours. I'll record it. Even if you guys can't make it, you can review it. It's not critical, I don't think, but it does. I mean, it's something that you have to do. And it is really important to database design. But it's something that I'll do in office hours, and it'll be fine. I'll add it and point it out in the lecture. Unless you guys want to see it now, I can keep going. It's your guys' call. Democracy. What do you guys want to do?
Leave it till office hours.
All right, cool. I'm sure JC's like, no, keep going. It's not like I just, traveled for like 48 hours or anything across the world.
The fact that he's not really responding there for a couple of seconds, that was a good indication that
Yeah, exactly.
he kind of zoned out there, so to speak. He was like, oh wait, I've just been called.
Yeah, right. All right, guys. Well, let's call it a night then. Hopefully I gave you enough information to think about for a while, right? A little bit of a fire hose. It's good stuff. This is a really action-packed lecture. They'll start getting a little bit more poignant and pointed as we go over the next coming weeks. So
Interesting.
cool. Yeah, database stuff is very interesting.
Okay.
Healthy.
Good night.
Definitely got the wheels turning for projects at work, actually.
I'm sure it does.
Good.
Sure it does.
Especially with CalSpace and how we manage our calibrations, which
Yeah.
JC knows it can be a mess, especially at a smaller company.
Oh, yeah. I wish more engineers knew more about database technologies and database architecture. It fixed a lot of our problems as engineers and optimization and modeling. It really would. But, hey, that's why we're here, right? We're trying to fix those problems.
Exactly.
All right, guys.
Okay. Good night.
That was good, guys. Thanks.
You guys.
Yeah.
See ya.
Right. Thank you.